for all ex-Yahoos, I know it is a very nostalgic moment. You want to put that? Start with the mic. Alright, good morning everyone again. Welcome back to all ex-Yahoos. I'm seeing some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. Welcome back to all ex-Yahoos. I'm still some familiar faces. So let's start with my name is Raj. I'm here at MBA. I think we have to give it to him that he's always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which I want to always. I think we have to give it to him which
talk about what they are doing to reduce infrastructure costs. And some of us are like infrastructure. Talk about what they are doing to reduce infrastructure costs. And some of us are like infrastructure. They're also French, and they are going to talk about how French migrated a lot of workload, which are primarily AWS workloads. Okay, to graphic and they are going to compute environment, what will reduce your primarily AWS. So yeah, please go ahead and introduce yourself and start off. provides us the benefits of artificial intelligence, service as well as the price performance advantage of that. And this aims for market itself for 20% of
Also, this is presented as this is a blog link. You can visit and check out how we are building more than 400 plus services across AWS account. So this is based on LinkedIn, and also this is presented as enhancing your this is a blog link. You can visit and check out and how we are building develop more than 400 services across AWS account. So this is based on LinkedIn, and also this is presented as enhancing your this is a blog link. You can visit and check out and how we are building develop more than 400 services across AWS account. So this is based on the blog link, and also this is presented as a blog link. You can visit and check out and how we are building develop more than 400 services across AWS account. So this is based on the blog link, and also this is we have observed for now. So till now, these are the changes that we have done from our end, like SRE platform. What changes the developer has to do is they just have to update the Docker file with the multi-arc image that enables them to use build the service image in both of the architecture, AMD as well as ARM64. And in Jenkins file, they have to update the build command with the Docker build. Like they just have to build add a parameter, and at the backend of it, it will build their image with buildx, and it will enable them for AMD64 and ARM64. So it's just a two-file change. No code change is required from their end. So any doubts?
And regarding that rollback, I would like to add, say some developers was trying, want to see to save some cost, and they are using say native compiled languages like Golang. And if they first migrate to Graviton instead, if they don't see benefit, they can roll back. So that's what rollback.
So when I move to our key takeaways, first of all, the cost saving, like AWS promise up to 40%. But for some of our workloads, we can see the on-demand price is less than 50% above. So as I told you that everyone wants to save AWS costs, so that was one of our driving factors. Also, Graviton adoption is much smoother for nodes. Like most of our services that we migrated are of Java. And for compiled languages like C, C++, Python, Golang, we still face some package compatibility issues. Like as in the issue, like some of them are still not ready for ARM-based processors. So that we are still observing, and we are building.
So Python is actually interpreted language, but it has some packages like NumPy, which is NumPy. So that breaks So that's
Also for third-party software, we have to ask the vendors or providers like what are their roadmap for towards ARM64 support. Like it can be like Datadog or like Word or etc. Whatever you are using, you can ask if the software support AMD64 architecture. Any doubts?
Just a question. So for all the cost savings and all of that, does your account have the computation and the assumptions fixed? Because I think those are key to understand because everybody makes a marketing pitch and goes away. But then how do you make sure that that is made visible and transparent?
Yeah, so we have tag-based clusters, and we are observing the change, like how much we are saving as we move from India to platform. Also, coming back to the question, we have done performance testing as well, like um, passing same load, like whatever RPM we are expecting towards intent-based service as well as the ARM-based service. And we have observed similar results, not as much as AWS software, like 20% more, but we have observed at least the similar performance we are getting from that. So that's why we are keen on moving towards more of our workflows towards that.
My question was not from performance perspective, more from functional perspective. It's very difficult to guess which signal library will be breaking. Yeah, because that has system, right?
Yeah, so that we are checking at stage level only. Like we have two environments. First of all, we are checking like migrating whatever services we have and stage environment. It can be Java, Python, or Golang. Then we are asking them to like migrate or like push image to prod and then we can test.
Okay. So what you're saying is you have for automated unit test cases
Yeah.
and functional test cases, so you can guarantee to large extent it will work.
even say some Golang packages create build. The build phase only becomes
Yeah.
even deploy.
So what are current plans for future? First of all, as I told you, like we are doing performances for more of our workload that we can adopt for Java. It can be other languages like Python or Golang or let's say Kong environment or whatever we are already done. Also, we are also looking for Java 3 evaluation. It is still not available in 80.1 yet. Looking forward for let's say next quarter. So that's all. Any questions?
Also testing. What do you mean that? What testing you go through? What testing application control?
Like we are relying on the tag owner something for testing, but yeah, we have
our sample use case. Sample deployment because then we provide something to developer. It will be tested before so we have our test use cases where we can run our own test pipeline. Then we deliver that cluster to developer. So and we do per testing on those sample pipelines. And when those works fine, then the cluster is developed. That is how we notify all developers on their channel. Whosoever is interested, first they try on their T3 services. And if they find it well working on prod also, then they migrate T2, then T1. So gradually. So
yeah, like non-user
Attention, no AMD isn't CPU power management found.
I think you need to change your basic images as well.
Yeah. Yes. Also, the change for this one Docker file is for the Kindle base image.
it means only those who have to change which are using the app or they have not changed since long when only one hardware. But newer images are always both multi-hardware. So they may not. Only people who are using older images.
Or if you are using any custom software in your base image.
And those images are also built by pipeline. So automatically those images are updated.
Other than the services, are you also trying to use Graviton based like RDS instances?
Yeah, we have already migrated to like approx if I say like we have 40% or 50% migrated to in our use. But last year we have like 90-95%, and for open services still in progress. So yeah, we are adopting Graviton and managed services as well.
Any managed services, how has it been any project?
Like if you are on the latest version, for example, for MySQL, the base like minimum requirement is version 8. If you are not on version 8, then you have to first migrate to it, then you can just directly update the instance side.
Excuse me, I'm curious about one thing. If you take out the cost component, let us assume that if I take out the cost,
Yeah.
what's the percentage of advantage in it? With all these things,
I think this can also enable you to have your service to be multi-architecture. Like let's say you have a large scale event, you will have a choice of running it on, let's say, Intel as well as the Graviton processor.
Graviton, let's say. Tomorrow, AMD says, everybody's using Graviton, I'll hack up the. Okay, let's assume you are best.
Yeah.
Now, the cost of Graviton is same as Intel. Now, considering that they are best state, so what percentage of advantage?
So with the native compiled language, we have not seen much advantage because C is much better on native compiled, like Golang and C, or Rust. And only, only like interpreted language like Java. Yeah. So those are we have seen like we can save cost, and those are like because they are using subset of instructions. So those are.
So coming back to the thing, I have just one more. If you take this, remove this cost component out of it, because you know, so sorry, so let us if you take the cost component and the cost savings are out, and we're talking only about the performance or competitive whatever. Have you considered optimizing these the code itself, the code itself?
Yeah, that
and then you see the performance difference is very high.
So we have tested with the Golang because it generates and really optimized code because it prevents developers from unoptimized code.
So not for people.
Not much different. So Golang, that's why we have told the developer not to migrate there because we have seen not performance gains and as well as the pain of like maintaining upstream. If upstream
Golang, what you have to do is you have to update the build state as well. Like you have to build the binary in ARM64, then you have to build your token in ARM.
All that is it not happy to run.
But interestingly, isn't the Golang thing available for ARM64?
Yeah, it is available.
But some criteria, some criteria. So, for example, Kafka is not still available for ARM.
Yeah.
So that's what.
The major aspect is that third-party software, MySQL, Kafka, Scuba, certification should come from ARM. So, are they certifying it saying is Graviton ready? I don't think anyone that is technician look at it. They are on mercy of them. Other one question to ask. Challenge is what you say, non-technical. Asking engineers to do testing, they are very comfortable.
So they already do testing after every build, right? Create and stage or
So that's why we have like given flexibility of rollback, and we have in pipelines we have unit tests and other things integrated. So those things help us in like catching the problem before we actually going to the problem. So that helps.
And it's more about like how they are being motivated to resolve the issues which are actually built on corporate.
So that's why same thing for Golang. That's why we and not encourage the developer to migrate to Graviton because they need to build two binaries. One form.
We don't want to add any new page.
Yeah. So we told them not to migrate Golang based project because Java already compiles in intermediate class 5, which runs actually on it. So that is easier to migrate without a single line of code. But for Golang, we have to compile multiple binaries. At the bit phase, we have to compile, and two binaries should be present in kind of Docker, so that and based on architecture, depending on the runtime, it picks and runs that binary.
So one question on platform side. So as you guys are saying, like underlying infrastructure is basically renaissance of VCS. So why not DKS? Since we are talking about the production grade and to do this gas testing, so it will be very useful for.
Yeah, we are evaluating EKS as well. For not all of our workload, but yeah, for some of our workload is already running EKS. But yeah,
for exchanges, we are thinking about.
Because since you're already in the cloud native base, which means organized applications,
yeah,
it will be useful for you guys.
Yeah, so Kubernetes is like for ECS is fulfilling all our needs for stateless needs. So that's why we have not migrated. But we are evaluating and we have provided provisioning for developers.
It's
They can
2:30.
complete the deployment from ECS to ECS.
We have supports
Yeah.
Two things. I think first one is your build time was having been.
It's not, you get first time only it is slower, but the developer is deploying multiple times.
Also, it is pattern. Like it's not like
The last part is fine, but the first part and then building it again for the other half.
also,
No, no,
I think
means we can expand more depending on the load.
Second thing is, thing a lot of people are discussing the performance differently. And I've also seen a lot of companies which have moved to Delta face this issue, and that's why they've only moved a percentage of their traffic to Delta and majority of traffic to AM. For example, if your latency decrease from 30 seconds to 100, getting a 20% increase in cost, a decrease in cost, that
yeah, that we are not.
So that's why I told them, that's why we have given them rollback. If they say, see, don't getting any
also
performance
we have,
benefit, they can roll back. So the question is, what sort of workloads have you identified actually benefit from Graviton, or there's no difference to benefit of the cost program? What is there some certain types of workloads that may be more suited for Graviton rather than other ones? For let's say a web service side thing.
Like for Kong, we haven't migrated yet. We have yet to evaluate how it performs for Traveler.
What?
Kong,
Okay. But so mostly performance benefit we have seen when it is more CPU bound the Java and it is more network bound. So CPU bound is better on Java. Yeah, in Java. On Java.
On
So,
Java.
so the JVM is better performing on the.
How do you guys like perform the benchmarking of the performance thing? Give us some criteria of
Yeah, so we use a locust for like purpose testing. Okay, so it is also runs inside pipeline.
so do you have like some specific number of requests or
Yeah, that we are comparing with Intel as well as now.
And in that locust developer can increase or decrease the load based on what is being doing. Mostly done in state for.
so are these architecture supported by load balance or something or
Yeah.
load balance?
So it's load increase, containers increase, horizontal scale.
And you mentioned about network. How is network performing on Graviton? Same like network workload. It's performing the same or is it
Yeah, perform.
Yeah, it performs same.
same?
Not so much of a spiky workload, but yeah. So you told that it can be a build time can be increased. Like you can see it's parallel only. Like ARM 66.
Single architecture build is always fast, but in parallel is little slow compared.
What was the initial thing that prompted you to try Graviton? So in my previous work, the paying of the multiple reducing cost the only thing that they were using Graviton for, and you might have gotten some performance boost for that. But yeah, what was for Craig? What was the initial thing that is?
Initial was
Yeah.
and they have
Because we have put the value. Thanks, Akshay and Mitesh. Our next talk is from Israel. Please go ahead.
Hi, good morning, Dr. Mark. So we are from India. Myself and Ajay. We are from we are working in the data engineering side. So we are building the data pipelines to solve the customer use case. The latency for our pipeline will be 3 to 5 seconds of latency. So I'm Chandrasekharan, working as a staff engineer in Institute, having 11 plus years of experience. In Institute, I am working last 4 years in data engineering side. Prior to that, I was working 8 years in software engineering side. So I can hand over my to my colleague Ajit.
Hi everyone, I am Ajit. I work in the data engineering team along with Chandra. We work on batch processing as well as stream processing solutions for YouTube. And today we'll be discussing about building real-time streaming pipelines at scale at YouTube. So this is the agenda for the presentation tonight. So we'll discuss a bit about Intune and how we are analyzing real-time applications here. And then we'll be talking about the challenges that we have been facing recently and what kind of solutions we are looking at. So Intune has majorly four products. We have QuickBooks, which is a banking product, accounting and bookkeeping solutions are being handled there. We also have TurboTax, which is a tax filing platform, and we have Credit Karma, it's a personal finance tool. And lastly, we have Mailchimp. So Mailchimp is a marketing campaign automation tool. So these are some of our tools. So where do we need real-time data analysis? So our main focus here is on QuickBooks. So this is where we are trying to do the real-time analysis and benefit our customers using these analytics. So QuickBooks is basically a small business and self-employed banking tool. They can do invoicing, expenses, and many other things. They can monitor the cash flow, and also it helps using the analytics and insights that we give them. It helps them grow their business and expand into different ways. So where does real-time analytics come into play? So before using Intuit as a example, I maybe use Swiggy as an example. Swiggy, I think most of you might know, is a online food ordering platform. So in Swiggy, we have options of ordering food. So let's say that I am one of the customers of Swiggy. I'm a user of Swiggy, and Chandra is one of the marketing team members from Swiggy. So if I order, in first case, let's say I place an order of around 10,000 rupees. So in this case, it's a nice order for the company. It gives them more insight into what kind of food I like and things like this. So they would like to engage more with me. They would like me to use the product more. So something like a hooray message or a promo code or some kind of a discount would encourage me to use the application more. So something like this we would be handling using real-time analytics. Another example would be suppose that I moved from Gujarat to Bangalore, and initially I was not using the app more, and now suddenly I have started using the app a lot. So the marketing team would be really interested what promoted me or what encouraged me to use the app more. So something like that. If the marketing team has more insights into that, then they can make marketing campaigns designed on the various aspects that promoted me to use the app. And also for me, it's beneficial because I can easily engage with the app more. So these are some kind of circumstances where we could use real-time analytics. So now using the same analogy, we can come into QuickBooks. So in QuickBooks as well, we need to perform real-time analytics on our PPO online users based on their activities, and based on these activities, we can get various insights from what they are trying to do. So based on invoicing or expenses or other activities, we can basically define whether these customers need to be updated to an advanced user or what kind of services would be more beneficial to them. And from marketing perspective as well, we can get intended right messages through the right channels for them. And this is something that we would like to handle using real-time analytics. So moving ahead, what is a payoff moment? So payoff moment is when the customer realizes the true potential of the application and something that he truly benefits from. So some kind of these moments, these milestone events is something that we are trying to capture. So that is what we are calling payoff moments here. So let's use the Swiggy example again. So if I place my first order, then I have successfully used the entire workflow of going through the menu, selecting the right food items, and doing the payment, and finally getting the order. So something like this is a milestone event for me. And I would be encouraged if I have more discount or promo codes here, something of sort. So similar to that would happen in QuickBooks also. If I generate my first invoice, something like that is a milestone event for us. We would like to encourage the user to use other features as well. So something like a promo code or a mirror message or something of similar sort would be really helpful for you. So real-time processing at scale. The first question would come up like, why do we even need real-time analytics? Why don't we just hard code some kind of a logic here? Like if you do five invoices, 20% discount, something of this sort. So why do we actually need real-time analytics? Why do we need a backend setup to that goes through the entire setup, brings back the new insights, and then pops up the message? Why so much set? So it actually brings in fluidity and dynamicness to the entire project. If we have some kind of a monolith setup where we have hard-coded things, the personalization level goes down. Also, tomorrow if you want to expand it to different domains or even completely change the way we are gathering insight, something of that on a scale without having a real-time analytics would be very difficult to maintain. Every time we have to do something different, we would have to redeploy the entire chart, keep the system up and running, and things like that. So if we have real-time analytics in our system, it makes it much more easier to maintain and also it has more impact. So before I move into what real-time analytics does, we would like to cover what a domain event is for us. I think many of you might be knowing what domain events are. Basically, we can define it as a set of information that can be used by other applications as well as the marketing team or insight team to do analytics on. So I'll take the Swiggy example again. An order here. So something like if I do a first order, it has various details like what is my contact number, which restaurant did I order from, what was the order amount, and things like this. So this is an entire package. If I package it into one header code and I pass it to a payment portal, so from the credit card details and other details, they can do the payment for me. And also based on that, the another event would be generated, and that event can be again captured, and we can get more insight from. Similar event come in QuickBooks as well. So if we see, we can create a new customer here. So in QuickBooks, we have an option to create customers. So here we have an example where we have header and payload, where the payload has customer details like contact number, full name, and other things. So if you see, information like this would be really helpful for a marketing campaign, or even to get general information to other applications like payment or invoicing.
You can go. You can join the. Yeah, I joined. I think for time so much.
So I hope the domain event part was clear and what are the use cases that we are trying to handle here using the real-time setup are aggregations. Aggregations like count, sum, percentages, filtering, windowing, things like this. So count would be the number of orders placed, sum would be the amount of orders placed, things like this where we would like to get aggregates and develop campaigns on. So these are some of the use cases for which we are trying to get the real-time analytics. So what is our scale? Currently the project started around 6 months ago and we have currently around close to 50 attributes onboarded to the real-time analytics platform. By end of next year, we are planning to get close to 2,500 attributes and all direct attributes, as we say, uh, onboarded to the real-time analytics. And let's I will just hand over to Chandra. We'll talk about the architecture in detail.
Yeah, thank you, Ajit. So I hope everyone got the idea why we need a real-time data. So maybe if maybe you I take the same Swiggy analogy. So you are doing some order like okay, you reach some milestone. Maybe today you have ordered 10 orders. So as a marketer from Swiggy side, so I want to send some promo code. Maybe like okay, you ordered 10 orders today, so use this promo code to get 50% off in the next order, right? So if I send a message or a coupon immediately in real time, so customer feel happy. So he can use the product more. So if I'm using the batch processing, right? Maybe I send this coupon after 24 hours. Maybe customer may notice, may not notice that message. So we are losing our customers. So if you send in a real-time data immediately, maybe if you are using app, right? So immediately you will get a pop-up, right? Okay, you have our so you have used you are ordered 10 orders today. Please use this coupon to get 50% off in your next order. So that's what we need, a real-time data. Um, so so we are the data engineering team. We are building the real-time pipelines. Before that, before going that, why we, we, uh, we should not use the OLTP database to build this kind of aggregation, right? Because your OLTP database is tightly bound with your product. If you are running this kind of analytical query, maybe if new order is inserted in the order table, immediately if you trigger the query and if you are doing the aggregation, definitely your product will see the slowness, right? So we can't do this kind of analytics in the OLTP database. That's what the data engineering team came into picture. So we are pulling the data through CDC events or some kind of mechanism, then the data landed into our space. So normally what we'll do, we will run the batch processing. Maybe if you don't want the real-time data, or we will build the real-time pipelines to do the calculations. Then based on that latency, based on the SLA, we will produce the data to the intended customers. So yeah, this is a high-level architecture. Most of the people from software engineering, maybe I can explain what is a pipeline. So getting the data from source and producing, building all the aggregates and producing the aggregates to customers, the customer or marketers, right? So entire logical structure is called pipeline. The pipeline has various components, various logical components involved. So in this case, so as Ajit said, right? So whenever each event happening, each action happening in the QBO product, like you have created order, you have created invoice, each microservice will emit the domain event, right? So domain event will have all sufficient information to do the particular calculation or to derive the particular insight. So if you take the Swiggy analogy, so some you placed some order, right? So you ordered pizza from Domino's, right? So that event, right? That event has all the information, like what's your user ID? So what is your order ID? Then restaurant ID, how much you have ordered, right? So it has all the information in the single event. But in database, it may be logically it may be 5 to 6 tables, right? So you need to join 5 to 6 tables to get the entire data. But the domain event will have all the data. So you can use the domain data. You can able to derive the insight without querying any other tables. So that is the reason why the product is emitting the domain event. So in this case, I have portrayed 3 domain events like vendor domain event, customer, invoice. So whenever the new vendor is created in QuickBooks, this vendor domain event is triggered. Then that event is landed into the Kafka topic. Source team has a responsibility to push the domain event into the Kafka topic. Then we came into the picture, the stream process which we built. So this stream process will consume the data and do all the aggregations. Finally, these aggregations are pushed to our downstream Kafka topic. From there, the insights get stored into customer insight service. That is one product into one product. So from there, customer will get push notification, or maybe customer can pull, or this notification, this data is pushed to marketer. Can you move on to the next slide? So here I can explain what are the various components involved into one pipeline. So as I said earlier, so QuickBooks is providing the domain event. So domain event has all the information. So this is a Kafka event. So it has the header and payload. Header has some necessary information whether this event is a create event or update event or delete event. The payload has all the fields like what is the information about the order actually. So what's the order ID? So how many orders you made? So all the informations. So once this data is landed, then our this is our stream processor. So this is our processing code. So we have used Apache Beam as a programming model, stream programming model. Why we choose Apache Beam? Because there are a lot of other solutions also there, right? So you can use spot streaming, you can use Flink, you can use Kafka SQL, right? So why we choose Apache Beam? Because Apache Beam is the concept of write once, run anywhere, right? That's the one concept. So you build the code. The runtime you can choose based on your available system. Maybe if you are using Google Cloudflow, right? You are Google Cloudflow, so you are a Google customer, then you can run this code in the Google Cloudflow. But if you are in AWS customer, you can run on the EMR, right? So maybe you can use the Flink runner. So your code won't change, but you can choose the runner based on your environment. So that is the flexibility. I think I need to connect.
I have one question. So you have shown the Kafka. So it put to Kafka. So is it able to handle the lot of throughput first?
Yes. So for one domain event, you have one Kafka topic. So there is around 64 partition as of now. So we can increase the partition size based on the load. Maybe we have a transaction kind of domain event. So every day we are getting 10 million records. So that partitions, the Kafka partition number of partition is more than 150. So we are scaling, scale out approach.
In partition, we cannot take it. Kafka.
Yeah, that we can't do, right? As per Kafka, we can't do. Yeah. If you want to if you want to increase, then you have to create a new topic. Then that is a migration process. You need to consume the old messages from old topic, and again you need to push it to new topic. That's a migration effort. But as of now, we are not in the situation. But
so you have not faced any issue in the first. Lot of traffic coming at us.
No. Yes, of now.
Say generally around day.
Yeah. Yes, of now we are not faced because we have started this program 6 months back. Definitely, we will be in that situation maybe in future.
Can you elaborate a little bit on the link runner, like what is the benefit out of it?
Yeah. Yeah. Okay. So Blink Runner will come with a state store, right? Actually, it will support an inbuilt state store, like a large city. That's one of the benefits we are getting. Then it has the control of storing the state. Then checkpointing is happening seamlessly compared to the Spark streaming. Right now, Spark streaming also comes with a large city, right? But when we are explored, that time we thought, okay, Flink Runner is a best suit for our use case. So we have used Flink Runner, and only we are using Flink as a runner, but Beam as a programming part.
So I mean, if you were on Databricks or something, that maybe are you on Databricks, right?
No, right now we are not in that.
So if an organization is there, I mean, in that case, Spark streaming in the background, right?
Maybe.
So in that environment,
Maybe. So then we are using Redis for the Elastic Cache. Redis is Elastic Cache because we want to store some information out of your runner, actually Flink Runner, because this RockCD is come along with your Flink Runner. If Flink Runner killed, right, you can't access the data from outside. So we are using Redis as our aggregator store. Aggregator means whatever aggregation you are calculating regularly. There's a for the customer ID 123, he created 10 orders for today, right? So this kind of information we are storing in the Redis. Maybe can you move on next slide? So once we got the domain event from product, then we are getting the previous state. Okay, I am the customer. I have ordered 9 orders today. So those information have already stored in the Redis. Now I made a new order. So we got the domain event for the new order. Then we will get the information. Okay, how many orders this customer made today? This information we have already stored in the Redis. So we will get the data, and based on the logic, whether increment or decrement or sum or average, based on that we will do the current aggregation. So in this case, this customer already created 99 invoices. Now we got a new domain event for create invoice. So we are just increment the count. Though this is the output payload. Currently I mentioned only 2 fields. One is a customer ID. So customer ID 1, 2, 3, 4. He made 100 invoice today or this month or lifetime. Okay. Here we have various kind of metrics. So this data is pushed to customer insight service. From there, it is notified to the marketer. So marketer has a set of business logic based on the organization need, right? So maybe they will send a push notification. This logic will change based on the use case by use case, right? So if you take this wiki order, right? So you made 10 orders today. Immediately they have to send a push notification. Okay, you made 100 orders today. congratulations, maybe you can use this code to get 50% discount for next one. But maybe they're sending cumulative count for month wise. Like, okay, this August month or this December month you made 100 orders. So those notification we are sent as a mail that is not recording as a push notification. There's a real time only, but they send us a mail. Sometimes they will conduct a campaign. Maybe they're targeting for some location, right? So they will send a campaign messages also. This is the end-to-end flow. So the latency for the real-time data from domain event get generated to the aggregates reach to marketer is 3 to 5 seconds of latency. So currently our stream processing, our area is taking 300 to 600 milliseconds as of now. But as for your question, maybe if you are getting more load, if you are getting more lag, definitely you will see some deviation. Definitely that is a potential area we are looking on it. We need to resolve that also. So how the pipeline deployment looks like. So this is a normal software engineering life cycle. So whenever we get the new requirement, we build the logic. Then we have to do the testing in our local. We write the clean code. Once the code is ready, then we will package it. There's a map and build packages a jar. Then jar gets pushed to the central repository, which is owned by Azure. Then once jar is pushed actually, so our runtime, we are creating the Flink runner on top of Kubernetes because that's you can easily scale in, scale out. So this is the managed service provided by the Intune. Um, uh, so we will spin up the new cluster. Then while spinning the new cluster, then we will define so how many cores required, what is your RAM size. We will provide all the informations. Once server is spin up, then after the we install the Blink runner on top of the we will deploy the code. Once your pipeline is ready, it will take 3 to 4 minutes to come up. Once it is ready, then based on the informations provided in the jar, it will consume the data from source topic and it will do the aggregations based on the business code what you written. Then it will publish the metrics to the output Kafka topic. And then along with that, it's always pushing that logs to the Splunk. Along with that, we need to monitor our topic very closely. As question, right? So, what is your Kafka input messages count? What is the Kafka output message count? Is there any lag? Is your cluster is performing well? Is whether underutilized your RAM size or overutilized? What is the CPU usage percentage? Right? So we need to track all those informations. Then only we will get to know okay whether this pipeline really doing all the aggregation in real time. So if any lag, right? So we are seeing huge lag like okay, one lakh message is not consumed from input Kafka topic. That time we will miss the XLE. So we need to monitor the entire stuff. So we are pushing this information into the Wavefront. It's a dashboarding tool. From that we will create the dashboards, and from the dashboard we are setting the alerting mechanisms. Right. So if the CPU percentage is used more than 90%, so you will create alert. This alert is notified to the respective developers and crew. Then if anything comes, then immediately we will jump in. If overutilized, then we will just scale out or scale it. We have automatic scaling scale out approach also. Sometimes that will take time to get scale out. So sometimes the manual intervention is required, but we are looking for better solution to solve it automatically. So what are the challenges we are facing right now in this approach? Normally if you want to write code, right? So that will take some time. So if you see this, there is first phase we have to write a code. Then once the code is ready, we have to test in local. Then sometimes using mock data or genuine data, or sometimes we generate the data from non-production environment. Then we will test a jar. Then we will verify all the aggregates. Okay, fine. My aggregates are aligned with the customer requirement. So now after that, we create an artifact. That artifact get pushed to the central repository through CI/CD. Once that is done, we will deploy the jar in non-production environment and do the testing. And if everything fine, then we will promote to production, then verify production data also. Then finally, we will ask the customer to verify the data and everything done. Then we will finally sign up the UAT, right? So this is a simple normal software development lifecycle process. But this is the process everyone following in the industry. But the problem is, as per our scale, we need to onboard 2,500 attributes by end of next year. For each attribute, we have to go through this entire cycle. So that is a very painful job. So how to scale the team, right? So whether we have to 10 people or 50 people or 100 people. So that's the first thing, right? So maybe I can take a simple example
It's
of
3
how much
o'clock.
time it requires to onboard simple attribute. So if I'm taking this example, right? So I need to find total number of customer created for the particular QBO company. So the code development it takes 5 days. Maybe I need to write 5 to 6 Java classes. Then I need to write a JUnit test cases. Right? Then I need to test in locally. Then once I feel okay, code is ready, then I need to spend another 3 days to test because I need to create a mark data or I need to produce the data from E2E product, some column case testing, everything, all the test cases I need to cover. Once that is ready and feel comfortable, then I need to create a pipeline, I need to create artifacts, I need to deploy it, I need to verify in E2E production environment first. Roughly, yeah, we took the mid path. So roughly it takes 10 days of time. So one sprint to onboard one attributes. So that's the problem. So if you want to onboard 2,500 attributes, we need 25,000 days, right? So this is logically impossible to reach that milestone. So we are in the situation we need to find something that should help us to solve our problem to reach our milestone without spending too many resources on this project. So how to scale? So based on our experience, so we need to when we are exploring some tools offering by other companies, then we read out a lot of the articles and what we are thinking actually how to scale because this is a hard problem to solve, but we need some solutions to solve our problem. So before going to that, actually, I will explain what actually we are doing inside in the processor. Okay, how we are doing the process, how we are doing our calculation, what are the various operations are involved. So as I said earlier, normally we will consume the data from a Kafka topic. So the payload has is a domain entity, right? So domain entity has all the fields. It's a full package event, right? Maybe for our calculation, maybe we need 5 to 10 fields. So if you take the entire message, if you are passing from one container to another container, or one CPU to another CPU, that takes time. So what normally we will do, we will extract the fields only which are required for our calculation. So then after that is the lightweight object. Then we will do the deduplication. Sometimes maybe the production source side may send the duplicate event, but we had agreement they won't send the duplicate event. Maybe that Kafka producer issue, the producer has restarted. Some reason due to some reason may sometimes we are saying duplicate also. So we have the small window like we are storing last 3 hours of information in the last TP. Then using that information, we will drop the duplicate event. Once that is done, then we will look up some tables, some static tables or some tables which is fed by some other pipeline. Once that is done, we have all the information. Then finally we will do the aggregations based on the user requirement like some increment, decrement. Finally, we are pushing this aggregates to downstream storage. So these are the 4 to 5 operations as of now we are doing as our processing logic, right? So these are the 5 operations. So what's the thought process? Okay, why we need to write these 5 steps or 6 steps for each and every attribute? Why can't we build something as a generic? Maybe the logic we can define outside your code. Your code is generic enough, intelligent enough to understand the logic which we have defined outside and convert as a code on runtime and build the logic and derive the aggregates and send it to downstream. So that's the idea first we came into our mind. So based on that, we came up with some solutioning principles. Okay, we need to we have a problem. So we need to build something that is reusable across all the pipelines. So I don't need to write same flow again and again, right? So second one is a low code no code approach. So I can write a code once. So with minimal change, I can able to onboard the new attribute. Second, that's the second principle. Then definitely we need to improve the productivity because 10 days per attribute is not acceptable, not possible to reach our goal. Third one is a consistency. Whatever you are developing, that should consume across all the pipelines. Consider I am writing one pipeline, Chit is writing pipeline two. But both are doing the same work, but maybe the class name changes, some business logic changes. He is doing exception handling very well. He covered all the corner cases, but my mistake, I missed important exception handling. That also not got in the PR review. Just approved, just went to production. Both codes are similar, look similar. Both are doing same logic, but his code is running fine in production without any issue. But my code is get failing for some due to some reason because some bad record or something, right? But both we are doing same code also. Logic only differs, but his code is running fine. So we don't want to be in that situation, right? So maybe because 2,500 reports, eventually we are going to create 700 to 800 pipelines. Out of 800 pipelines, if 100 pipelines are failing daily, right? Then this our engineer life is hell to fix those 100 pipelines every day. So that's the problem. So we need to build something that should be consistent across all the pipelines. So these are the four solutioning principles. First we thought. Based on that, we have explored a few solutions. But the first one is the Flink SQL. So that's offered by Flink. So here the Flink SQL is aligned with all our principles. So we are not going to create any code because the processor SQL processor is smart enough to understand the SQL and convert as a logic. Then we are going the low code, no code approach. Because the developer is not writing any code, he is just writing the SQL. Maybe the vendor one, maybe I'm writing SQL, how to read the data, how to do how to do the applications. So he is writing for customer. So development will take one time hardly, sorry, one day hardly. This constitutes across all the pipelines, so developer productivity also increased. So we thought, okay, Flink SQL is the best fit for our use case. Then when we are doing the POC, then we found some gaps. Like here, there's no clear way how to maintain the state. So because we need to maintain the state for some use cases, like as Ajit said, right? So he's an inactive customer for Swiggy for a long time. So he moved from Gujarat to Bangalore. Now he start using Swiggy. So he's moving from inactive to active. Okay, so this guy is active now. So I want to send some promotional code to keep him engaged, keep him to use this product, right? So we want to store that state information in our processing state store method RCP, because then only we can immediately can do this aggregation and we can identify, okay, this is the new user, we can send the promotional code. So there's a no clear way to maintain the state, and there's no clear way to how to clear the state. Then we have to write a lot of UDFs to store the data into Redis and read the data from Redis. So a lot of gaps. So we thought, okay, yeah, this Flink SQL is good, but it is not solving our problem fully. Then there are some gaps. Then what we thought, okay, why we need to move to different solution? Why can't we build something on top of Beam code which we are already using, right? So as I explained earlier, so we are normally doing 4 to 5 operations for all the attributes. Nearly 99% of use cases match. So as I said earlier, why can't we build some generic code? Why can't we expose business logic as a config or some other medium outside? So your code is intelligent enough to understand the config and convert as a business logic. So we built a generic code for each operation, like it's based on the solid principle, right? Single responsibility principle. So each code will do single job. So read generic operator will only read the data and do the extraction. The dedupe only will do the dedupe. Then we build the generic classes and we are chained. Then what is the advantage for this actually? So developer no need to write a redundant code because we are building a generic code. Developer can use a stable artifact instead of creating artifact for his pipeline, right? So that's the advantage what we have planned actually. Then second one is the business logic is the config. And so what we did actually, we exposed or we extract the business logic from business code and write it as a config format, like a YAML format. So developer no need to write a new code. He has to finally he is going to write only YAML file to define his logic. okay, what are the fields you have to extract, how you are going to dedupe, what are the rules you have to execute, right? So developer is going to define in the YAML day. Then this config file is dynamically pulled from remote repository by your generic processor, and it will execute at runtime based on few set of parameters which are passing by the developer, like which config file you have to pull, right? So this based on these parameters. So what is the advantage we are seeing? The developer productivity has increased, so he no need to spend 10 days. Then sometimes we are using the logic is same, only few conditions are differ, so we can use the same YAML, just override what are the conditions, only the conditions which are differ between the both YAML. Then you need to go through the CI/CD because these are configs automatically synced with your Spring Cloud server. So this is the before state. If you see here, right? So here I have defined the three pipelines. So vendor pipeline, customer, and invoice pipeline. So each pipeline we have to write a separate stream processor code. This vendor stream processor is intelligent enough how to read the vendor code, vendor domain event, and how to do the aggregations. Then developer B writing the customer stream processing, developer C is writing the invoice stream processor code. Right? This is the before state. Then after state, this is the generic processor. It's developed by group of developers. Right? So we are using this stable version. This config, the respective config is pulled from config service at runtime. It will execute and produce the aggregate. So here, there's no duplicate effort to write the processor for each and every attribute. So that is advantages for building the generic processor. So this is the sample YAML structure, how the business logic structure, how it looks like. If you see here, we have defined a series of operation. So first operation, I need to extract, right? So maybe I need to extract 3 fields from header, 2 fields from payload. So I have defined in JSON path expression. So I need to get the entity extract entity injection, item potency, company ID, then active entity. So all the information I have defined in the YAML format. Then in the extraction operator will capable of doing this extraction from incoming event and keep it as a JSON payload. Then second operation, I'm doing the dedupe, right? So here I have defined what are the attributes you have to consider to build the primary key. So based on the primary key, it's going to drop the events if any new event, duplicate events coming. Then move to next one. So this is the final count aggregator operator. If you see here, we have certain set of rules. It means in coding perspective, it is a if condition, right? If this condition match, do this kind of actions. Yes, this condition match, do this kind of action. Maybe you can correlate with that one. So rule one, what is saying, if this create event, then it is active true. Then you need to increment the active count by 1. Then you have to add this user ID into active list, right? So it means this customer is active. Then if you are getting update event, then is active equal to false. It means this customer is moved from active to inactive. So just decrement count, decrement active count by 1, increment the inactive count by 1. Then remove this user from active list to the active list and move this user to inactive list, right? So this kind of business logic, maybe he will define in the YAML format. So our generic processor will understand this code. At the beginning, it will do all the calculations, and finally, those aggregations are pushed to our output downstream topic. So coming to the deployment, so in early state for each and every pipeline, we have to build the jar, right? So this jar get pushed to central repository. For each pipeline, we need to build it. Right? But right now, that entire flow completely discarded. So because the stable version has pushed to central repository after all testing, integration testing, unit testing, everything, right? It's tested, deployed into some sample pipelines, testing pipelines. If you the stable jar get pushed into central repository, so we are not building any new jar for the new attributes. Just we are pulling that stable version. Then next coding part. So whenever the developer get the new requirement, he is only writing the YAML logic. Then the YAML logic is YAML file is get pushed to GitHub repository. Then we have onboard the GitHub repository into Splunk Cloud Service. Then this whenever the file gets pushed to GitHub, it automatically sync with your cloud repository. So this generic processor will pull that file through API call based on the parameters which is passing by developer during the deployment. Okay, I need, this is my pipeline. I need to pull this file. You have to execute this file. That's a logic, right? So we are completely avoided that building side, but this side the config is very simple. You don't need to follow the CI/CD development. So I'm taking the same example through the after the enhancement. So my development take maybe half a day because I'm creating only YAML file. I'm not writing any code. Then my testing may take 1 day because still I need to generate some dummy data or I need to produce the data from product, EPA product, and I need to test it. Then deployment because I don't need to create any new artifact. Just creating pipeline. That also we have automated. Creating pipeline, deploy a new pipeline. So average it takes 2 days, maybe plus or minus 1 day actually. So so we have reduced from 10 days to 2 days our development time to onboard one pipeline. Still, we need to spend 2 days to onboard one pipeline. So it is 2,500 attributes. It takes 5,000 days roughly. So so yeah, we have solved some problems some extent, but there is a lot of scope to solve a lot of area to solve this problem. So how to scale it further? That is our question. That's what we are spending all our energy. The entire team doing a lot of POCs, and we are exploring different areas. So what are the solutioning principle, right? Okay. So we need to build some system, or we need to incorporate some system from market side that should support real-time injection instead of creating a processor for each pipeline, right? So that system capable of that system should capable to ingest the data from multiple input topic. Then it should have the storage and store it. Then on top of that, like you have database, if you relate to the database, right? The database has a capable of ingesting data in subsequent latency. Whenever the domain event pushes to input topic, the data available for querying in subsequent latency. Then that system should support to the aggregation on demand, maybe in different dimensions, right? So yes, current scenario to onboard 2,500 attribute, we need to create 700 to 800 pipelines. So we don't want to be in that situation. So if we are maintaining the pipeline, creating the pipeline, error handling, monitoring is a very hectic job. So we need to build one system on top of the system. System has a capability to ingest the data and keep it in memory. Then on demand, we will write a query. Maybe some other system continuously get the data from this source and send it to downstream. So right now we are taking 2 days to onboard the new attribute. Definitely that is not a accepted SLA from a customer side because in real time, maybe today we are saying the target is 2,500. Maybe in down the line, maybe next year, maybe the customer say, okay, I want to onboard another 2,500 attributes. That time we can't say, okay, give me 1 more year, we will onboard it, right? So we need to find some solution. Okay, 2,500. Okay, maybe in the quarter, maybe 1 month we can onboard. Maybe this 100 attributes are available in next week. So we want to give that kind of commitment, right? So otherwise it can't scale. So we are maybe here I mentioned less than 5 seconds, but we are looking less than 1 minute. Sorry, 5 minutes. We are looking less than 1 minute. Maybe can you? So we are looking for some desktop solution. So this is right now because every industry is starting. Uber also invest a lot of time to build this kind of solution. So hybrid transaction and analytic processing. So we have the batch data, like historical data in our data lake, like S3 or flat file system. So what we're looking, so we have some system to ingest the data. So maybe the vendor I can store in the vendor table. Maybe I can create a MySQL kind of table that this system is intelligent enough to consume the data and store it here actually. So we will create another process to query the data, maybe it's polling or pushing, that we need to figure it out. Then whenever the new data arrives to vendor topic or customer topic, then this system is intelligent to identify the change and do the aggregation. Then the aggregation should flowing to customer. So tomorrow, maybe that marketer come with the one requirement. Okay, I want to onboard this X attribute. Okay, source is ready. Yeah, source also saying, okay, I'm ready. I'm already pushing domain data, right? Just a few configurations we can able to onboard, and this new domain data is flowing to new table. Then we are giving some config to the daemon process. Okay, this new table is onboarded. Okay, listen this table also, do this aggregation, right? So by passing few configurations, this new aggregate should onboard with less effort instead of creating pipeline, building the jar, right? So we have simplified, but that is not a scalable solution in long time. So we are looking this kind of solution. So maybe that maybe a marketer want to do some ad hoc analysis, right? So instead of creating, I want to know this detail only one, so that they can't say create a real-time pipeline for this, right? So we have to expose some query service, so marketer also query on demand with minimum seconds of queries. So this is a solution we are looking. We are doing a lot of POCs. So we already explored Apache Pinot, Ignite, and Root because Pinot is widely used in industry, mostly LinkedIn, Uber. They are using Pinot for real-time analytics, real-time dashboard. So if using LinkedIn, right? So we have one feature who viewed your profile, right? So that feature is built on top of Pinot. Right, so Pinot has capable of ingesting data in sub-second latency. The data also queryable within a second, right? So they're using Pinot. So we explored Pinot, Ignite, and Root. Still, we are evaluating in terms of how to deployment, cost, all the other aspects. So this is a journey for last 6 months. So we have scaled up our application some extent, but still we are looking. So I want to use this forum like, okay, this is our problem statement. So if anyone has the idea, right? So maybe instead of Ignite, maybe okay, if you use this database or this system, you can able to ingest it, you can able to query very faster. So those kind of help I'm looking on this forum. So if anyone is want to share something, we will talk. I think that's all from my side. So this for time for Q&A. Maybe number of customers, number particular side. So maybe if you take a Swiggy analogy, right? So number of orders the person made today. So if you take a we took say number of invoices he created. So each everything is covered. Yes, yes.
So what is the shortest time span of the attribute? Like you are recording some attribute for short time, like 105 minutes or 10 minutes last.
Now, right now we are not doing windowing. Maybe that's our roadmap. Right now we are calculating. As of now, we are calculating the lifetime event. So how many orders created, how many invoices this person created till now. Yes or no lifetime agreements, sorry, aggregates. We are doing percentage, but windowing is maybe the next quarter we will do this. Because if you are going windowing, right? So if you use the current system, this is very hard to implement. Okay, I want to get the stats for last 1 month, last 30 days, right? So you can't keep all this windowing data in the Redis. You can keep, but doing the calculation is very tough. So if you have this kind of solution, maybe that's a query change. Okay, give me the number of orders for last 30 days, last 2 hours, last 5 hours, right? So, but if you are taking the current architecture, that is possible, but so it's a hard way to achieve it.
So this historical analysis that you're doing right now for any event, domain event, where is that data? Like, are you making?
Whatever data pushed by source that also get materialized into the data, like means S3 file.
That's in your current architecture.
Now, also it's currently it's persistent that is actually. So we are using batch processing to do the analysis. As we are using a Spark. We are doing that historical analysis, but that I not put in the picture actually. But what we are looking, so we need it because right now it's a two process. One is a batch process that is running in that different EMR, different set of resources, right? So stream we are doing in different code. So we are looking one solution. You can do batch and streaming also. If I see the proposed solution, right? So we will inject the historical data into the database. So this table has all the data, right? You can do historical analysis, maybe last 30 days. You can do whatever you want. So that is a scalable solution. Right now we are doing the batch process separately.
Okay. So based on the domain events, when it gets pushed to the Kafka topic,
to generate the aggregations, you are pulling data from your transaction systems and then pushing it. It's kind of a lambda architecture.
Yeah, whatever we are looking is a lambda architecture.
In your config files, you had some kind of code for the conditions.
Yeah, okay.
Do you have any way to test these business logics?
Yeah.
Do you have any ways to test this business logic?
Yes, actually. So what we'll do actually once we have a stable version of the jar, so we can pull it on local. Then we can able to connect the config service through local also. Actually, we have the policy ID. Then we can generate the dummy data. Maybe in local itself, you can produce produce the data into local topic, and you can test this based on your conditions. Then we can generate the data in E2E that you can able to consume from your local system. That's a real data. Because some corner case you can't test from product like a duplicate event, right? So whether my logic is dropping duplicates or not, because you can't create a duplicate event from product, right? So those data we will create from local. Then in our machine we create a topic and we are listening that topic. We are generating the duplicate data and we are testing whether our code is working fine or not. So all the logics are verified in local. Once everything ready, then we are going to integrate and we will verify E2E and we will promote the version.
By local, you say your developer's laptop or something like that.
Yeah.
I'm just curious, like you mentioned, like after doing this architecture change, you were able to reduce on the testing time as well. So initially it was 3 days, you changed it to 1 day.
Because I don't need to test my code. I need to test only my logic. Means the YAML file actually.
JUnit test cases this one.
Because that's written for your generic processor, right? So one more thing we want to working on it actually. So JUnit may be covered based on some set of data, right? So maybe today I want to onboard invoices. So that is coming in the different data. So that's a thought process, but we are not started actually how to pass the data, just data from outside. So your generic process maybe can execute your latest attribute also, sample data for the latest attribute, maybe for which we are going to onboard. Right now it's executing based on the set of mock data.
Okay, it's just data.
Yeah. So we can't update the jar, right? Every time we can't update it. Then if you update jar, you need to pay. So we are going with the no code approach. So build is ready. Maybe we need to find some way to ingest the data.
Do you have any framework for your testing as well?
No, yes. Thank you all. Thank you for giving the opportunity.
Lot of detailed deep dive on the architecture. Thanks for all that. So according to the schedule, we are on time. So we'll break for lunch. Shamuga can guide us. We just move to the cafeteria. Okay. So there we go. Package there.
You know.
What's up?
My package is basically like this, like so that
It's 3:30.
so that is right. So that kind of accuracy is one of that legal guidance and that is you have to get correct on the page. That is that is telling us.
I felt so right. Whatever we are building right time, it go wrong at any time. So if you want to do the weekend session, then we are relying on the batch.
So
Right, then batch data take time to.
batch will be like minimum to minimum at all times around like we have a small like batch kind of thing, but still they take on an average to reach to the historical month after completion. Around 30 to 1 hour. So
Essentially, yes, that's what.
but your use case is like you want the real time integration, batching aggregation, and then immediately with it, I see my techniques for that to reach there. That is because you want the marketeers to like immediately say send a promo.
Yeah, promo code, right? So you are
so that they can probably buy more using that.
Yeah, you're looking at like you made order, you created invoice, immediately the notification should come.
So I think I was solving the problem, but with scale is the issue.
Scaling for so many attributes.
If it's undecided, it's manageable. The problem is.
It's not about the 100 actually. It's like as your number of customers increase, they might ask you demand for any number of activities.
Yeah. Today, 2,000, maybe tomorrow 5,000. Yeah, we can't ask markets to pay for 1 year.
Customer says that I take 500 activities, give me return down to work, and my marketing will look at the data, and then immediately I will just say business for the can do. Then another customer says, it's not like a single Swiggy platform. You are having different customers. So one quick customer might say 100, other might say 5,000. So you have to be that flexible also on that, right?
We did something. So we had a chat with Apache team and so they're okay with the injection part. The problem is doing the aggregations into downstream. That's a problem. They told we will support.
You talk about that SQL, like the SQL. IDBMS is a classic case for solving these problems at the base level or the medium level. But they can, as soon as you aggregate, like say, for 5 or 6 dimensions that are coming into different tables, you make query and
create SQL bottom is streaming. So you don't need to query here. Whatever you are getting data, right? And about that, this is streaming is clear.
I saw that you saw, but the problem is like as number of attributes increase, the SQL will become more very heavy.
And state
So that is like similar kind of DB problem, right? Where the complex queries are not able to might run for hours or MySQL product. So this is SQL RDBMS setup is not the answer for that for sure. But think about it, surveying and you did that.
I have a question. So, unit counts, how do you do unit counts? For example, I want to find, suppose, I have 10 addresses. I add one more, you have to find how many addresses do I have.
That based on the domain entity only.
Hosting does the kind of setup where it does not allow to see it. If it is coming up there, that window will be for
So I'll be happy.
No, my requirement is that. Because it's taking
but there are six times.
how long
As I said, right? In advertising, we are in that case. Like, they actually have like really good campaign on an hour. You learn for days, but you start a campaign and you want a campaign to run during the peak hour. So the peak hour, so what we do is we take 5 minutes aggregation and
even the unit
so the remote time is they will get a sense of okay, how that campaign is inspiring to like pumping if it is going good, there are a lot of conversions are coming in. Identity pumping probably both coming right now. So within 15 minutes they get an idea of it, and then they are looking at more money or like more money. This is the problem that we are working at a virtual level of at a heart, 1 hour, right? So we are and we are able to provide data some sense of sovereignty, but 5 seconds is like hyper. What do you say? You are very super aggressive.
Now we are not proper. Okay, now we are scared of what he is saying that unique user window in all those kind whatever architecture we are having, right? So this achievable, but it's very hard to maintain that state. Okay, what is the last unique users for last 5 minutes, 10 minutes? How many state we will maintain the edits, right? So this very it's not scalable solutions.
We had similar problem. In doing we had to build a solution. Using Redis only we built some custom solution. The unique aggregates, that was the problem for us.
Yes, Redis,
Compared to how we use inactive to active.
suppose, but we don't see that real use case for the unique test. We are solving at some extremity. If that comes, maybe we will see some.
That was the main two requirements for us. One is the video, another one the unique counts at real time scale. So
For you,
for payments, we had to do it within like 100 milliseconds.
yeah. So yeah.
But processing
That with windowing custom solution which we built on Redis, that was handling taking like 5 milliseconds, 10 milliseconds. But the unique count we still haven't figured out how to get it down. We thought
What is the use case of that unique count? What you are actually solving with the unique count?
suppose in case of Swiggy, what they told, right? I want to how many unique food items have I ordered?
Okay.
In real time. Suppose I ordered something to
This is the child is not So see, this is the most difficult session generally because Meadows is and the blood will try to get to digest all those stuff. Okay. So this session is the most difficult session for the speaker to keep everybody awake. Okay. So let us help the speaker to run this session because this is a lot difficult session. Because those of you who worked at Yahoo at some point in time know what UDB means. It's probably the heart of this. Nitesh used to sit behind 2 cubes behind me, okay, and his boss Sachin Dase, who is still at Yahoo probably in US, okay. They used to have those fights. Yes, some data. Yeah. Okay, so I still hear those films. Nitesh was like a friend from IISc, okay, smart grand. After landing into Yahoo, with Sachin Dase, all those things. Sachin used to think, IISc वाला बंदा क्यों नहीं करता? Yes. Okay. So you see how time changes. So I'll let the stage with Yahoo now. Okay, we'll listen to how they did the Yahoo UDB migration. Is Anshu connected? Click on WhatsApp.
Alright. Thanks everyone for joining that after the lunch. Maybe art session for me also. I'm Suresh. Uh, I work at user data platforms team at Yahoo. I've been with the company for about 10 years now. I'm joined by Sushil.
Yeah, I also joined Yahoo somewhere in 2011. I've been working with Yahoo's data platform since then. So, yeah.
So today we'll talk about what user database at Yahoo is. It's a homegrown NoSQL DB solution at Yahoo, and it's been running for more than 25 years now, ever since the beginning of Yahoo. And we'll go over its sort of current architecture and its limitations, and how we evaluated options for the new architecture, how we did the data migration and traffic migration to the new system. So UDP, as it has been running for more than 25 years. With that comes a lot of legacy code and legacy application features that have been running forever. It's in essence a NoSQL database which stores and serves user profile information like name, age, date of birth, favorite sports team, favorite stock symbols, etc. It is a high throughput, low latency system. Very critical for normal Yahoo functionality, like users accessing mailbox or users accessing finance or sports pages at Yahoo. And the data is present in 5 different data centers, and it's globally replicated. And it serves traffic in a hot condition. So all 5 data centers can take read as well as write traffic for any given record. Here are some of the numbers to show the scale of the system. We have about 3 billion records in the DB, at any time serving up to 2 million QPS traffic. The latency is in under 10 millisecond range. And so now we look at the current architecture of the system. So in each data center, we have about 128 hosts, and the data is sort of equally partitioned among all the hosts. And whenever a host receives a request, either a read operation or a write operation, it internally identifies the target host for the partition, and performs the read or the write operation over there, and returns the data back to the client. Now, this is happening in one data center. Behind the scenes, asynchronously, this data is replicated to all other data centers, as well as to a secondary copy in the same data center. So we maintain a replication across 2. So each cluster has 2 copies of the data for redundancy, obviously. And this asynchronous replication, it's again built as a homegrown transaction journal-based replication system. It's sort of a peer-to-peer replication, which is decentralized. Now, with that decentralization also comes specific challenges. For example, if for user A, if you're writing key 1 value 1 in data center 1, meanwhile for the same user, key 1 value 2 is being written on a different data center, these transactions are at the same time sort of crossing over each other and getting replicated, and they could end up in a state where the first server that received the request will end up with V2, and the remote DC which received the earlier request will end up with V1. Now, because the system was designed in such a way that we don't guarantee eventual consistency. So this is one of the challenges in the system.
So eventual consistency was not guaranteed. There are chances that the entire system for a user will be inconsistent.
So although we expect of our clients certain behavior in their usage, For example, a given user would typically show up from one geographic location, and if they keep connecting to the same data cluster, you don't have issues. But in real world, systems are not working like that. They end up making cross data center calls, which is what causes eventual inconsistency in this case.
About that, I have written a singular program based on Mozilla taking the source of.
You still remember that Mozilla ID. And it was about that I we took the Mozilla ID with the DB and tried to figure out what that means. Now the Mozilla itself is not there. So this is one of the challenges with this system. Obviously, when we
one question here.
Yeah.
The initial system, when I left it 10 years ago, was basically a file system based. Is it still the same?
In this current architecture, it is still a file system.
It is still a file system.
The software layers have been.
So you call it NoSQL, if the system actually predates the term NoSQL by 20 years. And yeah, truly it's NoSQL because it doesn't create interest. Yeah, it's totally TP.
NoSQL only in the sense that it doesn't.
It doesn't do this. So it's still basically a file system that gets replicated across hosts.
The software layer is that fast. The software layer on top has been revamped into some C++, Java, and replication system. I don't know if TXR used to be there. Has been replaced.
No, I wasn't never not in UDB.
Yeah. So software layers have gone through changes for improvements. The underlying the file-based storage is still the same. And obviously, when we want to provide eventual consistency to the clients in this use case, because even for a very few users, if the data is going out of sync, it's going to cause bad experience for those users. When we measure the inconsistencies, the numbers are low, as in less than 0.5% will be having problems. But for those users, it will be a bad experience. So one important thing we wanted to address was in the new architecture, be able to provide eventual consistency. And then obviously there are other challenges in the system as well. The API and data storage layer were sort of built together. Of course, that's easy to explain. The main problem there was the data storage was done in such a way that it uses a fixed partitioning scheme and a fixed replication pattern. So this basically prevents us from being able to dynamically scale up or down the cluster depending on the load. And we wanted to address these issues in the new architecture. And so we basically did a build versus buy evaluation and looked at several KV solutions that are available in the market plus open source. I'll hand over to Sushil to talk about the evaluation.
Yeah, thanks, Suresh. So in the previous slides, we have seen our current system and some of the limitations, right? That we have consistency issues, we have fixed the partitioning scheme, all that. Now, when we are building a system for the future, we wanted to build it for it in the right way, and it should be scalable, all those things. So in that aspect, we have defined the goals here, right? So we want to be operational cost effective. So OPEX should be low there. So in current, let's say if you refer to the legacy system, in a data center we have about 128 hosts. So for that we have to invest for those many number of hosts. And we have such multiple data centers, and if we want to add more capacity, then we have to add another cluster like that. So there are such limitations. So that comes with the operational cost. Then next is the maintenance overhead. Always when you're having like 1,000 servers, you have to patch them, you have to release on them, you have to do multiple operations on that. And next is the throughput that we wanted to improve. Currently, our cluster capacity, if we set up that the current hardware footprint that we use, it offers up to 1 million TPS per cluster. So if beyond that, if we want to handle, then we need to add another cluster because the partitioning is fixed. So there is kind of bottleneck there. So that we wanted to address, and we wanted to look at for the future. We wanted to, let's say, per cluster itself, we wanted to deal with a 3 million TPS. And right, as you might have seen that this database is this key value store is mostly read intensive, and our write requirements are, I think, nearly 100K kind of thing. So we still wanted to have a good number there to estimate the future capacity. And some of the functional requirement, it's like we wanted to serve low latency than the current offer. The current system operates around 8 to 10 milliseconds. We wanted to see if it can be reduced it by 50% when we move to a new system. And obviously, the consistency, I think Mitesh was suffering one of the implementation or automation that we have done to fix the account. Always this account issues or record issues has been a problem because one is the network partition we replicated. There could be network issues, so data comes in out of order and it get applied. So in that case, we have inconsistency issues. And other is like application which is not poorly coded. Like for example, there is a load balanced application, and your application write is happening in one column, but at the same time, due to a shift, it is happening in another column. So in that kind of retrial logic and all those things can cause issues. So consistency was a problem there. So we wanted to see how we can address that when we move to the new system. So in that, keeping all these requirements, we wanted to evaluate like what are the options available. So we have considered both commercial as well as the open source systems. So I think I can go to the next slide. So I am not going much detail. It's already visible here. This is mostly the TPS side evaluation that we have done. So in this, you can see on the axis, TPS is measured. So here you can see the arrow spike in our evaluation. Arrow spike was standing good, and we kind of decided to go with that. And this is the low latency wise evaluation when we did for other comparison with the other solutions in the market as well as in the open source world. Now, when I say this arrow spike is standing out, it doesn't mean that it is true for all the cases. Like you might be having different thought that why Cassandra can do it, but our case is this statement or this slide is specific to our use case. So in our case, mostly our record average size is 10 KB, and max is like 128 KB. So that is our data size pattern, data that we want to store in this key value store. That is the per record size. And the next one is the kind of lookup. It's mostly a point lookup and mostly redundancy. So all these factors we consider. This is the load test and the measurement that we have done, and in that we have found arrow spike standing good for us as a solution. Now, when we take what actually, this is actually some of the factors that made us to decide, other than the numbers, what else made us to choose arrow spike as our destination for the data store. So there was a question like the file system based storage, right? So that file system storage, we wanted to plug it out and we wanted to put a new storage there. That's where this arrow spike is going to come in play. So arrow spike, as the first point says, arrow spike showed significant improvement over existing solutions. So existing solution in terms of capacity, like I mentioned, the current cluster with 128 hosts, it is able to do 1 million TPS. Arrow spike can do much more. It can get up to 3 million TPS. And that is our latency is also, we saw much more improvement when we compare with our existing system. So the other factor is the strong consistency. So arrow spike offers strong consistency within the cluster, and they offer eventual consistency across globally replicated different data centers or clusters, right? And arrow spike also has an option of dynamic reclustering. So this is like dynamic repartitioning, which is one of the downside of our existing system. Our existing system has a fixed partition, and it can maximum you can scale up to is like 128 cores in the cluster. So you cannot go beyond that. Aerospike has much more bigger partitioning scheme. It's again similar distributed logic and all those things like that. If you will point to a distributed host, but their partition scale is like 4096. So you have much more option there. You can scale. You can actually support multiple partitions and scale it. And it also like in the existing system, if one host going down, like we mentioned that currently we have a replication factor of 2, right? So a data record, there is a copy in the same column to handle the redundancy and to make sure the high availability. We have another copy there existing. That is 2 level of availability is that. So if one is going down, we have to make sure that the other is serving, and meantime we have to make necessary work done to on-call needs to engage, and necessary work needs to be done and make sure that the other one is coming back to serve the traffic. Otherwise, it's a single point of failure at that. So the last point is Aerospike support like different data models. Different data models in the sense they support different storage options by which you can further boost your performance. For example, Aerospike stores the data. They allow you to store the data based on the requirement. You can either store the data in the block devices or the memory, or you can do both. So based on your choice and your data requirement, like how redundant, how high available, and based on that you can decide. So we can put it on like Optane kind of a hardware where you can persistent memory you can put and you can get a better performance. So they give multiple options there. So with considering all this, Aerospike was our option. So the current architecture we have already shown. So this is the place we wanted to take our application to. So our clients here and REST API, like any other web serving workload, we wanted to put a auto scaling, all those things and scale it. And this is your data store. So this is what we are replacing the existing file store with the Aerospike cluster. Yeah, so we have now identified our
one question. Can you go back to the previous one? So you said dynamic partitioning. Does it mean the partitioning is done in a way so that your nearest geographical user can access faster, and whenever such pattern changes, you basically readdress the partition to another location, or is availability?
So partitioning is within the cluster.
Within the cluster.
Yeah, so it is like these are same identical copies. This will take care of replicating whatever is there in this to this. Same way, if the write happened, that write is replicated here. The data, so how Aerospike stores that data, or how existing stores that data, that is what is decided in the partition. So current existing Unity partitions into 128 partitions. It's like and each partition
double copy.
then you have some limitations there. Okay, right. So to answer your question, this partitioning is not for distributing the data to one region to another region. This is within the Aerospike or within the whatever storage solution what we have.
The repartitioning comes in when one of the nodes goes down. Right. Automatically Aerospike would internally transfer the data what was supposed to be there in that host into other hosts so that the replication factor is made. Right?
Yeah, sometimes that is expensive also, but again there are ways to make it faster as well.
Yeah, in existing system we don't have that. That is one of the limitations. Like I said, right? If a host is going down, it's a single point of failure for that partition, not that host is hosting it. Then we have to work on make sure that we rebuild it.
You have 2 replicas so you can make it faster.
Here it is automatically taken care. So if let's say we have 3 hosts in the cluster and one host is holding 10 partition, if that host is going down, that 10 partition is moved to other 2 hosts. So if you will have, I just gave 3 host example, but Yeah. Okay. So next is the data migration. So in the data migration, now we have identified our solution where we wanted to store our data. So we wanted to move our existing data to the new solution, right? So when you are migrating the data, some of the points that we kept in our mind, right? So data migration source is critical because this is Yahoo's critical data store. For Yahoo to function, this data store is a must. So you cannot afford any downtime there, or you cannot put excess load with the migration traffic. So all those things needs to be taken care. Next is the consistency guarantee. So these two systems, new old system has a uh, legacy DB is not eventually consistent, and other one is consistent. So you're trying to write something from an inconsistent place to uh, which is ensuring an eventual consistent. So you have to take care of that. Next is the migration. How do you want to do the migration, right? So we have to control the migration and the whatever is there in the production, it has to be stopped when you are doing the migration, and that after the migration is done, it has to be applied so that every data is in sync. And we wanted to control the migration TPS. Sometimes we wanted to do operate in high migration TPS when off-peak hours happens, and all whenever we are executing all this regular our day-to-day operations with users reading releases, all those things should be unblocked, right? It should not be a blocker for the migration. Now, the migration of data with live production traffic on the new system. So we cannot wait for the new system to take the traffic until everything is done. We wanted to take a benefit of this new cluster as soon as we can. So what we planned is we migrate the data in a form that okay we do 10% of migration and put some traffic. Okay, then incrementally you can do the migration in parallel. So your system, at a point, the legacy as well as the new system will coexist.
It's 5
And
o'clock.
legacy will have 100% of data, and the new system will have 10%, 20%, 30%. Like that, you will incrementally migrate it, and at the same time, the new system will be serving that traffic as well. Whatever 30% is available, right? So I can serve that. Why should I waste my resources for the entire migration to happen? So the next one is the repeatability of the migration and the observability. So that is one thing we wanted to address. Like we wanted to we are doing multiple times, right? So we wanted to make sure that it is repeatable, and all those times the pages, everything needs to be measurable and observable. That's why we wanted to have this as a metric, as a log event, and all that. Next slide, please. Now data migration. Now we have identified that okay we want to do the migration, and in the assumption before going to the migration strategy, we already talked about the inconsistency, right? So in the existing system we have 0.5% of inconsistency. Let's say assume that. So what are the options for migration? So when you think a database migration, what you will do? Okay, you will do some export from the source and you will import it to the destination. So that is one option. That is the strategy one. Pick one golden cluster where you think that okay, data is most good, and you migrate that data to Aerospike, and then fix the all inconsistent records for that region and migrate the full traffic. So the problem here is Aerospike is eventually consistent, right? So when you are and in the legacy system, you have a lot of inconsistencies. That 0.5% is there. So that 0.5%, even that 0.5% is a user impact, right? So we don't want to cause that. So what is the other option? That is what the strategy 2 that we have got about it. It is like before migrating the account, we check all the regions and make sure that whatever the data we are migrating, it is in the correct shape, right? So, and migrate only the valid data to the Aerospy cluster, which provides much more consistency, and do the remaining 0.5 percentage migration after fixing the data at source. Don't take them to the new system, because you don't want to bring to ultimately, like, we want to maintain. Um, yeah, ultimately we want. Can someone mute Sachin? Yeah. Okay. So yeah, yeah, we wanted to maintain the consistency there. So we decided to go with the strategy 2. Okay, in the strategy 2, what we are doing is we are migrating the consistent records, and after migrating the consistent records, we are also putting some traffic to. We are migrating the traffic, the real user traffic, to the new system, because only 0.5 percentage is the inconsistency issue. So we don't want to hold the cluster usage until we fix everything. So what to address that, what we have done is we have built a fallback logic for our API. So API will do check the mod new store, and if it is not able to find the record, it will fall back to the legacy. So with that approach, we could take actually the benefit of both the clusters efficiency, as well as shift some of the traffic. When you are shifting traffic, you can do the remaining migration and fixes without much production risk.
Fallback strategy did not introduce more latency into the system.
So when we are doing it, it will do the parallel itself. So it is only for the smaller percentage of the calls, right? So it's like 99% of the accounts or records gets migrated to the new system, and only 0.5 percentage is getting impacted, which is much more win than keeping them for like operating for like next couple of months for 10 milliseconds. So instead, we are addressing a larger number of users and serving them in 5 milliseconds.
So one more question. The writes, the two clusters are running parallelly.
Right.
The old cluster and Aerospike cluster. Writes, did you allow writes to the new cluster?
Yeah. So right specifically, we will talk about it. I think we can answer that question. It's the later part of this slide. So we are currently I'm covering the data migration part. After that, we will talk about the traffic migration. At that time, we will tell like we will more delve into. Yeah. The timeline wise, so we try to do this in 4 steps. So first one is at the 0 level. What we have done is we have taken a snapshot of DB. Snapshot of DB in the sense, don't think like a export of your Oracle DB or this thing. You define a time point that you are doing the migration. So from that, you identify how many records that you are going to migrate. So from the snapshot, you extract the primary keys of the record that you wanted to migrate. Then check the consistency of each record as a batch, and consistency check against all the legacy clusters, and make sure that they are all consistent, and only the consistent one get returned to the Aerospike. So during this process, before the one starts, whatever we are doing is we are going to backlog the transaction journal from the right path, so that when the migration is like 2 to 5 days of activity kind of thing. So when we are doing migration, so at that time we want to hold the production fields. So we hold that with the backlog, and after one is completed, we migrate X number of accounts. After that, we are going to drain the backlog. So when we are draining, both legacy and new Aerospike cluster will get the complete data in sync. Now we verify that we cannot assume that it is in good shape. So our migration accounts, we are going to check and make sure that migrated accounts are consistent across the legacy clusters as well as the new destination where you are performed, right. Then, if there is a inconsistency during the training backlogs, there was a parallel write happened, and Aerospike has some value and older has different value, then you delete that records from the Aerospike store. So because we don't want inconsistencies, that we can reattempt that migration. So at the step 4, we have completed almost 99% of the accounts or records migrated. Now, next we will see how we are doing the traffic migration. With that, I will hand off to Suresh.
Thanks, Suresh. So now that 99% of the data is available in the new cluster, we are looking at how to do the traffic migration to the new system. So again, we had few challenges when we switched the traffic as well, since this DB is sort of heavily used by multiple Yahoo properties at any time. So one challenge was we wanted to do a very gradual rollout of this. So start with maybe 0.1% of the traffic to the new DB. Measure the error rate as well as inconsistencies for those users who are getting served through the new system. And if the error levels and inconsistencies are well within the limits, only then proceed to increase the bucket to, let's say, 1% and then 10%, and then take it forward to 100%. And at any time, if we find error levels higher than what we expect or inconsistency levels higher than what we expect, we wanted the ability to fall back to the legacy system completely because it's fully functional and serving its purpose. So we wanted that ability as well. And obviously, we didn't want any downtime to the system. And there will be continuous live updates to any of these records in any data center. And we didn't want to prevent that as well. So a DB migration would be very easy if you can put a downtime. And we didn't want to do that, obviously. And we decided to do the traffic migration in multiple phases. Even though it would take longer duration to achieve that, this provided sort of better resiliency and better reliability for us. And in the very first phase, we would sort of gradually switch the read traffic alone to the new Aerospike cluster, and while the writes continue to happen on the legacy system. And then gradually we would switch the write traffic as well to the new system. And we'll go over the details in the next set of slides there. Yeah. So this is one of the intermediate architecture where both the legacy system as well as the new Aerospike cluster are fully functional, and this is set up in such a way that still all the read and write traffic are served by the legacy system. So we have a separate API layer which receives the request from the clients, and they perform the read or the write operation using the legacy and return the response back to the users. Meanwhile, the legacy DB asynchronously replicates all the transactions that it receives into the Aerospike cluster. And as you can see here, both the legacy DB as well as the Aerospike, they do a geo replication to other data centers using their own logic. In case of legacy DB, it's the transaction journal based system that we earlier talked about, and Aerospike has its own cross data center replication logic. We call it XDR. And so at this point, we gradually shift the read traffic from the legacy to the Aerospike system. And the way we are doing that is, let's say we move 5% of reads from the legacy to the Aerospike system. The REST API here would send 95% of the reads to the legacy and send the 5% of the reads directly by serving from the Aerospike cluster. Since we didn't do data migration of all 100% of the records, we also have a fallback logic at the REST API to say, if Aerospike comes back and responds with a 404, make sure to go and check that the legacy DB does not contain the data. If it contains, serve it from there. So that kind of fallback logic helped us to move the traffic even while 100% of data migration is also not completed. And now we are looking at sort of beginning of the write traffic. Yes.
Is there any algorithm is related to the traffic migration? That what kind of data is migrated from legacy to DB? It can be bittersweet.
So in our data migration, our aim was basically to migrate all the 100% of the data. Now, during the data migration process, what we are trying to identify is go check all the data centers. If the data consistent and same value across all the regions, then it's a candidate for migration to it. Now, from the identifier itself, we cannot make a judgment whether it would be present in old cluster or new cluster. So we end up making the actual call to pick it up.
Kind of blind.
And since we have done 99.5% of the data migration, most likely you're going to find the data.
How did you reach the 99.5? Because when you are doing, you might be end up in reading the same record again and again and trying to write it in the error cluster and see it's already there. Those things will happen, right?
So when we were doing the data migration, just before this, at that point, only the legacy DB is serving the end user traffic. Aerospike is being acting as just as a receiver of transactions. So if you look at the earlier slides, so what we did was on the async replication path from legacy to Aerospike. Right now the Aerospike cluster is empty. We start a transaction journal backlog, and then we go gather the data that needs to be migrated, migrate the data, apply the transaction that have been backfilled so far, and once that has drained 100%, that's when we are ready to even serve one user.
Okay. One more question. Yeah. So data which has been migrated, there is a very much likely the chance till the 99% migration happens that legacy that write happens on the same record again and it's updated.
Correct. So there is asynchronous replication that you can see here. That is going to take care of applying any pending changes that started from T0. And there is a chance that the transactions are arriving out of order. That's where the consistency check enables us to both measure it, and in case we find the error, drop that record from the target system and re-migrate it.
So if the write is an update, it would be first sent to the legacy DB, and the reads would be done from Aerospike.
Yes.
So wouldn't there be some sort of a
So what would happen is if some clients are doing a read followed by a write, they are going to face a problem that the asynchronous replication path from the legacy to Aerospike has not caught up with it yet. We did have that problem, and in the initial phase, we started migrating the traffic only for those users who don't have the need for read followed by write. But as we went on and we measured the asynchronous replication latency, we kind of found that it was less than or equal to the same cluster redundant copy replication itself. So that kind of helped us to make the 100% shift, even though we didn't have the guarantee.
Yeah. We could have run like initial analysis of users who are like less frequent users. Those can be migrated.
In this data migration, it kind of did that. They take all the users, instead of blindly doing the migration, and split them into cohorts based on how frequently they are using the system, and first do the migration for them.
That's actually what I mentioned. Like we wanted to do in multiple steps, right? So that is thought process.
And before we switch the write traffic to the Aerospike cluster, this would be the existing architecture there. The client send a write request to the REST API, and the API layer connects to the legacy DB, writes the data, and responds success to the clients immediately. The legacy is asynchronously replicating to its own copies in the other data centers, as well as to Aerospike, which again would replicate to other data centers. Now, how do we switch the traffic to the new cluster? We basically took a dual write approach for this, where any write that comes into the Aerospike, to the API layer would get returned to both legacy DB as well as to the Aerospike cluster, and only then treated as success and respond back to the client. Now, again, if you do that in one flip of a switch, it will be an easy process, but we wanted to do this in a gradual manner. So what we did was take small percentage of traffic, let them go through this dual write process. The remaining, let's say 1% is going through the dual write process. The remaining 99% are still going to go through the legacy and follow the old logic. Now this 1% of the traffic, we would write to the legacy, and then we would also write to the aerospace. Only after both succeeds, we are doing them actually sequentially, and only after both succeeds, we respond first to the client. Now, the async replication path from the legacy DB to aerospace is still in place, and what's going on behind the scenes here is that when I'm bucketing 1% of traffic to the dual writes, that 1% need not be replicated through the async. So only the remaining 99% needs to be replicated through the async path. We added sort of custom logic on the async replication to do additional filtering there to ensure if the data was written synchronous to both systems, no need to copy it through the async path. And then again, for the records that are recently written by applications, we measure the error levels and inconsistency levels across the legacy DB different clusters as well as across the aerospace clusters. And when we find the data consistency level to be acceptable range, because there is always going to be live transactions that you can't account for when you're measuring the consistency. So it's not going to be 100% consistent rather 99.8. But when you sample and look at the reasons for the errors, you realize something. There are live transactions going on, and that's why they are out of sync. And when you measure them again later on, you see, okay, they are good now. So with that kind of consistency check, we were able to gradually increase the bucket to 100% on the dual write. Now, 100% of the write transaction, they go to legacy and then they go to the aerospace, and then only they return success. At which point we are ready to drop the async replication path.
The question is, if only a few transactions are going through the both the things, then how do you ensure that you are only returning success when both have been written? What is the sort of the flow logic that you have incorporated to ensure?
Correct. You are going to have a problem there when writes succeed on the legacy DB but fails on the aerospace.
Or vice versa.
Correct. But
how do we ensure that both succeed only then you do it? So do you have some other controller which says, okay, yes, this was the supposed to, because there are two cases here. One is the dual write coming in, and one is the one which was anyway supposed to only go to the legacy.
So things that are going to supposed to only go to the legacy, no issues.
Yeah.
If legacy succeeds, it succeeds, it fails, it fails. Then you need to write to both. We actually did not do it a parallel write there. Instead, we did a sequential write, accepting the latency cost. Go right to the legacy first. Once it succeeds, go right to the aerospace. Both succeed, only then return success to the client. Now, yeah, one can succeed, the other can fail. That point, our expectation to our clients, we establish is that you should retry until you get success. And
but the client who is writing to the async, the second write to the aerospace is being done at your end.
By the API.
By the API. It's not the client. The client doesn't know that what is happening, right? So if you guys fail writing to aerospace, for example, then still you can return success to the client because it is already returned to the
yes, but we didn't want to do that because aerospace we want it to be the source of truth going forward.
Okay.
So anything that is not yet returned to aerospace, it's not yet golden. Okay. And that's the reason we said first write to legacy, then write to aerospace. Only the second success is telling us overall operational success. And in case of failure there, the clients have an option to retry. Or basically what we are telling, like in any distributed system.
Essentially, any write to an aerospace, if it fails, goes as a failure.
And clients obviously don't know whether some part of your system has accepted it or all parts of your system failed it. That is not there.
That's where you go and delete the record from the CCTV.
We didn't take any corrective actions. The expectation would be that the clients would be doing the retry there until they succeed.
Okay. One more question. This green box test API.
Yeah.
So there are a lot of logic flowing here, like right here, succeed, do there. And I'm assuming there are a lot of different places where this call is being made because this is 25-year-old system. So how much developer support was needed? Like what are places you need to change? They thought it was all organized one single library, you change it there, it's everywhere.
Over the years, there has been some consolidation to reduce the chaos in the system. So in the past, the partition map of this system used to be in each of the clients. which possible big challenge will you want to take a node out of rotation. And over the years, some refactoring has been done to essentially to make it a REST API layer that all the clients do is talk to that API and do a read or write operation. Since we control the API, we are able to do it.
How are you handling the failed write events? Like after some retries, if it's failed, how are you handling?
Typically, the understanding there is that we are telling the clients, okay, 5xx error. We don't know whether we have saved this or not. To get a proper status, come back to and ask us again. So we kind of push the onus on the clients here to say, if we don't know whether we stored it or not, if you call back and get us, you may get V0 or V1. Come back and try. And once 100% of the traffic switch happened to the dual write path, at that point we drop the asynchronous replication from the legacy to the aerospike DB. And at this point, we are kind of ready to deprecate and remove the legacy DB. So once we build features like there are several features that are built on the legacy DB that are supporting things like change notification stream and taking a snapshot of the entire DB. And the 0.5% inconsistent record that we have not yet migrated, we would have to actually spend few months to do a proper fix of those accounts and migrate them fully to the new DB. Once that is done, we would remove the legacy DB and we would have the much simpler architecture that the API cluster or the DB cluster can be independently scaled. And these are some of the improvements we have tried.
And we have time, so 5 moments.
These are some of the improvements we have seen after moving to the aerospike backend. Obviously, with the aerospike software capability, we are able to vertically and horizontally scale the DB layer, and we were able to bring down the hardware footprint by almost 5 times. And in addition, when we did this new architecture, we decoupled the API and storage layer so that they can be independently scaled.
Can you zoom in on the second part? What do you mean by you reduced cluster footprint by 5 times?
So in each cluster, we used to have 128 hosts hosting the data. We were able to bring it down to 1/5 of that.
But the state types of hosts, because I would assume the previous one, because of the file system based thing, because memory was not a problem. Since this is this, I don't know what aerospace, but I would assume there are significant memory requirements.
Yeah, it's not very equivalent hardware, and there is significant memory need for this because entire primary key index and secondary index are fully built in memory. In addition, there is also another interesting feature they have basically use a persistent memory, so that when you reboot a host, you don't need to rebuild the index on startup, and that saves few minutes when you bring a host back into rotation.
That was in the previous system or
in the new system?
In the new system. So, now what about the power cost? This is just a question. I'm not sure whether anybody has looked at that. But 128 hosts with lower memory, lower CPU, and all of that versus. I mean, I'm just trying to compare the.
If you actually try to measure the amount of RAM put together, that is still much lower than the system.
But the power we have not measured. We don't have the data.
Just a question.
Like 128 hosts, if we take a look at it, it's like nearly 32 gigs.
Yeah, it was 64 kilowatts.
That these hosts are it's almost
more efficient hosts.
And obviously, Aerospike backend allows us to do.
Oh no, that's good. I just wanted to know, and you still maintain your data center footprint, right?
Yes, this is all on premises only.
Okay.
And Aerospike also gives you the ability to change the replication factor on the fly. If you don't want RF2, you want to increase it to 3. You give a command to the cluster, it's going to redistribute the data and achieve that. And as I said, we were able to use the Intel PMEM, which enables us to reboot a host and build the primary index very fast because it's kind of persistent and restored from the memory instead of rebuilding from the disk. And here are some of the latency improvements. From the legacy system, we used to have average of 8 millisecond latency. We were able to bring it down to 2 milliseconds while increasing the overall throughput of the system as well from 2 million QPS globally to probably handle 5 million.
So is this still on bare metal or you're trying on Kubernetes?
It's on the bare metal side now on the Android. Some of the learnings I'll probably quickly glance over. When we did the data migration, there are many challenges where we had to start over from the beginning. So we made the migration process itself repeatable. Go wipe the data, start the migration again. So we made that itself as sort of a repeatable module or a process that we did it 2-3 times over to actually get things right. And as we did this measurement of the errors and inconsistencies, we were able to identify issues in the legacy system which were causing the inconsistencies in the first place also. So it kind of helped to improve the legacy system even though get rid of it eventually. And as we also earlier said, the data migration, we couldn't aim for 100% perfection in moving data from the old to the new. So we made the architecture a little bit resilient to handle inconsistencies. Assume they will be there. Now, how do we ensure the quality is still good? And trust, but also verified. We built several end-to-end consistency checks, which enabled us to actually understand how well the new system is performing and how consistent the data is. Without that, we'll be sort of blindly saying, okay, we did the migration, all good. And 6 months down the line, you actually find problems. So yeah, spending time and effort on building tools to measure the metrics is useful. That's all we have. I'll open it for questions.
Thanks for was how much of the climate was for go through the entire environment and all type of
Just a lot of time spent on the design and architecture of it.
It's 5:30.
I would say like 6 months time frame. The actual migration timeline itself is rather small. The data migration probably took 2 weeks. Yeah. And the traffic migration 1 month after that. But most of the time was spent before that to plan how to do this.
And what kind of internal tools actually have built to basically, let's say, particular question you do like how you build kind of what kind of input have gone into measuring the parameters across the different benchmarking. So how did you do like what kind of parameters, what into that working benchmark the tools of the different databases? You ask two things, right? Benchmark the tools or benchmark the system versus the system also. Tools we won't be able to benchmark, right? If you benchmark tools, so not tools. What I'm saying is like have one the team built some kind of internal tools.
Yes. So for the initial benchmark of the different theory solutions, we did build it's basically Java code we built to do performance testing of the system. Pick a single type of anything we instance and build different database types over there. We obviously took help from other teams at Yahoo who were expertise in running those systems. There were teams which knew HBase very well, and there are teams which were running RocksDB and HelloDB. So we took help from them to build a solution on a single instance or a 2-node cluster, and then perform the same performance test against all of those and capture the results. It was internal tooling, basically Java based performance testing.
This is on bare metal server, like we have some monitoring tool to assess all the nodes.
there is sort of generic metrics and observability that we do at Yahoo. Sort of similar to Grafana and Prometheus, we have homegrown solution.
Is it Llama still?
Llama is still there. We keep increasing the version number.
So, one quick question. I mean, since you mentioned it's not open source, that means you're stuck with Aerospark. So, what kind of flexibility you have? Because it's a big decision, right? You're investing, and Yahoo hasn't been like that. So, what was the shift that led to this?
I think we made a sort of a big evaluation of build versus buy.
Okay.
And should we be
But it's
spending
a
time?
lock-in, right?
Yeah. Should we be spending time to build the infrastructure or rather build the application?
So there are two questions after that. Is PSN allowed it, or still PSN there or not?
It's not there.
PSN is not there.
No, PSN left long back.
Oh, okay. Okay. So then me question.
It's a library. This is not a SaaS. Like they're just
But
buying.
you might be paying for this.
Yeah.
And you don't have any flexibility to make changes.
Not on the board.
Yeah, not at that point.
Yeah.
We could make feature requests, but yeah,
You'll get
it's
the
not an
timeline.
open source software.
Okay.
They do have a free offering, but it's not open.
But they have flexibility on the price because they are one of the.
Yeah, once they become.
Once they become. Then
So those private pricing, I don't really understand. That's fine.
So now I get it. Yes.
Do you have any use case of spending your existing or whatever user base you have or node you have is sufficient, the same nodes remain the same?
Yes, so that's what I said, right? With the new system, we are able to deal or load test it to 3 million. So our current cluster capacity is 1 million, and we are serving that. And we are in the new system with the lesser footprint. We are able to get it up to 3 times per region per DC.
Understood. So my question was more on the lines. Aerospike can dynamically scale. All after you added, and what I understand, you are using persistent memory as well.
Yes.
Which is specialized hardware kind of thing. So do you need to add, do you run into use case where you have to add more nodes frequently?
No, I mean, at least for next, we are in the nearly 1 DC, we are doing around 1 million DPS, right? So we have headroom of 2 times. So we are able to serve the current traffic with the cluster, with the current footprint. We are not planning to add at least for next 2 years or so.
With this, you cannot move to cloud, right? It will be very difficult because you have specialized hardware.
Yeah, I think Aerospike also offers solutions in AWS or the cloud solutions out there. So we are doing the POC for that. Now, once that is there, it is like we will be kind of moving to a state where you have your REST API in a micro containerized world and storage in the Aerospike solutions. So we will run similar workload EC2 or something with the Aerospike.
You don't necessarily need the specialized hardware. You could run this whole thing without the persistent memory also. Only thing is that your reboot is going to take additional time, or you need to find a way to use the general memory to achieve that purpose.
One question around especially around traffic shifting when you like common based traffic shifting. I think like how to use the system to do architecture in terms of concurrency domain or
Scalability issues we didn't have because our legacy system was running at whatever 90% capacity. That's where we couldn't handle more traffic. When we built these new API cluster and DB cluster, we were sort of well provisioned to not have issues there. Even though the other aspect is that it's a very read-heavy system, maybe 10:1 or even 20:1 read-write ratio. So the write operations, even though they are very complex, the amount of throughput we were getting was not that much.
I have 2 questions. One is one last question because in a matter of time you have to get Sachin up. As an add-on to his question, like I've seen this trend, like Yahoo is more on-prem at the moment. Like, is this a general strategy, or like you have plans to move to cloud, and why is it so slow, the transition?
As a whole organization, I think Raj has mentioned earlier, we are looking at different cloud partners and moving our on-prem loads to cloud. So it's existing a hybrid.
I think it has two answers. The user database was never good. Okay, so they advertise that database which is revenue persistent. I mean, revenue sensitive. Those are theoretical thoughts for that.
It's a very vast workload. So we are trying to see what is the where we want to get into.
At some point, we will be in a hybrid fashion where we could take traffic for clients who are there in public cloud as well as on premises.
And then the digital transformation, which I talked about earlier, it's not about just the technology, right? I mean, for us, it is all about technology. But when you go up the level, they look at more about the business, the ROI, right? So I know there are cloud providers that are available, they are best in their field. But for Yahoo, what makes sense, right? If you are going to invest certain amount of dollars, X million of dollars to send cloud provider, what we are going to get in return? It's not just one day. So those decisions will take time. Technology wise, yeah, we can make a decision when we move forward, right? But business wise, it has to make sense, and that takes time, right? So they need to see ROI.
Okay, so I think with this we'll conclude this session and we'll invite. I've seen somebody wearing a 2013 T-shirt of a hack day, which happened here. Same with Pronto is here. So let me just. I'm not going to introduce Sachin from the YBLR perspective. I'll leave Sachin to deal with that.
So why PNR? I have to figure out where that all those names went.
Slack. Nobody uses IRSSI now, so all Slack.
How do I share your president?
You're already there.
So it's been 11 and a half years. I just realized since I came back into this building.
Welcome back.
Thank you.
Welcome, folks.
Yeah. So for me, I was in Yahoo. Then I went to do a PhD in public policy of all these topics, and came back, had a brief stint in the academia. Realized that public policy, academia was really not for me. I'm not a social scientist by any way. I like some bit of it, but so I'm trying to get back into technology. So Devansu gave me this opportunity. I said, well, let's make the most of it. So the topic I chosen is learning from tech depth. I haven't really done a lot of research on it. I didn't get enough time, so I looked up. So this is going to be a very, very sketchy presentation. I'm sorry for apologies in advance. You may be looking for something great, I would rather say it's going to be more of anecdotes from my past and what I think I've learned. UDP is one nice example of it.
Attention, upgrade to macOS Monterey.
Yeah, so the point about technical debt is I've got a very, very that's it. So this is what I essentially said is that the idea of technical debt was actually a metaphor coined by Ward Cunningham in 1992. And this is pretty old because I just realized when I was seeing this that the term, when I first came to hear of it, was almost 10, 12 years ago, but it seems to have been there a long, long time ago indeed. And the idea is that a metaphor of technology debt or something missing in technology as a metaphor for something which is financial is shaped by Lakoff has written a very good book, which this is something that I got out of my PhD program, so I'm proud of that. There's something at least that I learned from the PhD. My teacher actually told me about
the metaphor, the idea that when we think of metaphors as ways you are actually thinking of things in a similar fashion and you are attributing certain values to them without really understanding. So Lakoff talks of the idea that an argument is a war. You talk about losing an argument. Or time is money. You talk about losing time and money. And so, if you think of various metaphors, you also are thinking about the way you are going to frame the question or the way you are going to think of the problem. And that becomes very, very important whenever we are. So when Matt Cunningham talks about technical debt as debt, he's basically taking a financial perspective and we are actually attributing some of the ideas that we have in our real life about financial debt to what technology debt is. So there are ideas that debt may be good or it's bad, you want to pay it off, you should not be over leveraged. We know all these concepts. So some debt is bad. So all of these ideas are so the core idea behind is technical debt, as all of us know, that over time software craft comes up, things change, requirements change, and it needs to be fixed at some point of time. And if it doesn't manage, well, we get into a big mess. So as the UDB said, you have tried to do it over a period of time. It could have been done earlier. But then there are other points I would say is that there also is a time when the time comes to fix it. The way the reasons I've come to the UDB case is an interesting one because I have a small point on that. So Martin Fowler developed a taxonomy of debt which says that so on the y-axis we have debt which can be which is inadvertent or deliberate. You can take on inadvertently you can take on debt because you did not understand the requirements, you did some changes, you did some fixes, or you could deliberately take on knowingly that I am going to be in a big problem tomorrow later on. Same ways you could be recklessly doing it, I just need to ship it, I don't give a damn, or you could be okay, I know this is a problem. I know I'm going to have to come back later and fix it. And the challenge that in our 10th years or so, even more, the problem that technical debt was a bigger problem was also because there was skills between a developer and the operations, right? They just wanted to fix it, but also had to maintain everything. They are the guys who have to actually look at the consequences of debt, while the developers just didn't have to worry about it. So things when they really got broken, it was the guys in the people who were on call who had to wake up at 3 a.m. in the morning and fix things. Because somebody somewhere down the line decided to do things a different way. So I just so this is a brief idea, and the key one other aspect that has come up. This is an interesting book that I got. Ernst Kasman and Delaney. It's a pretty big book, so I just read a couple of chapters. Just looking at, but there's a lot more literature I realized on the technical debt concept that we have actually come. I mean, so there is a lot of work that has happened. So this is just very, very barely scratching the surface. So they say that it's not only software core, but it's the entire organizational culture which also contributes to technical debt. It is the way you build and release, it is the way you get together in the room to fix problems, all of these things. So you could have, and very interesting case that comes in mind is from my beginning years in the career, I was working at CDAC. And I was told that one of the ways people did the transfer of technology was to put the stuff in a hard disk and just give it to the other guy. And that's what he says, that he says that one guy had to leave and he said, give me a transfer of technology, give me a code, so he just passed the hard disk to him and said, yeah. So and that is, I mean, those are cultures that have evolved, people have, they are cultures, they are very, very disciplined. There are cultures where that's another. So you are an enterprise culture, and you have a different way of thinking. Everything is a database sort of a mentality. So you have organizational culture that plays a big part in it. You have the way the technologies have evolved, the way whether you're open source or whether you're Microsoft. And so there are lots of things that play in ensuring that you come to that. It's not only about code; it's about a lot of places. I'm just talking about learning from the real world phase, and this is 2008 UDB. We had a UDB problem, and this problem was the root cause was that the way UDB had been designed and was managed was that we treated network bandwidth to be a resource. And this is very, very true in those times when network bandwidth was the scarce. The problem we used to face was that we received a complaint that some users were not able to log in early in the morning on a weekdays or continuously over there. They used to face login failure. When we found that the problem was that because at that time UDP database was not being hosted in Bangalore or in India, it was actually hosted in Singapore. And we had a total bandwidth of I think 2 Mbps or something between here and Bangalore. So when there was a surge of people coming into the, and when you do a much more deeper things, and you're talking about 2006, 2008, when internet was not so common at home, people used to go to their offices and they used to log into their from the office piece. They used to log in and we used to see a surge around 9 a.m. or 10 a.m. of a lot of traffic coming in, and because it was throttled, it used to the Singapore route was throttled, so it had to go all the way to the Pacific coast. And that increased significant latency, and that is why we used to see these failures. So this was the consequence of a particular design decision that made a lot of sense at the particular point of time. But if we had continued, I don't know what happened to them, what they did, but if we had continued to work in that fashion, you would have seen. So these are things that we need to address over here. Like we need to understand whether the underlying assumptions have changed, whether you have the way people are. So continuously, we have to keep on evolving and trying to fix. So I mean, this is just one of those. And then there was the other one. This is my favorite story: the data bus. Who knows about Yahoo data bus? Other than all the old guys. Huh? So Yahoo data bus was a Yahoo patented technology by what was the name of that guy? Patel, right? I think the senior scientist who was so there's a patent on that, and that was actually a way that media used to get all the news feeds and everything bundled into through a particular package using email as a system, and from there it would be distributed to all the various properties. So we had a hub. I think it was 4 machines across 2 polos, 2 in each that were running. We used to get these feeds coming in from somebody was using to send those feeds, and then these feeds would be dispatched onto other properties which were processed. So everybody had moved to using HTTP or RSS as a means of getting their feeds. But we have this product which is still continuing to run because somebody somewhere needed it. There was nobody who really knew how the thing worked. The code was arcane, complex, complicated. There was no documentation at all. We were told that, okay, this follow machine is shutting down, we need to migrate it to a new one.
Attention, software update.
I had to do it, so I got a couple of interns together. We said, okay, let's do a VM design. Let's run this, install all these packages, figure out what works, what installation, what you do need to do, document the whole damn thing. And so we actually documented the whole entire installation of building up a machine from scratch. And when we were said we were ready to do it, then we did the physical migration. So all this was done. Then this guy who was the sole person who was managing data bus on a 24/7 call, one person in Bangalore office here says, I have had enough, I'm going. So, program manager boss, अब क्या होगा? बंदा आएंगे वापस? He said, okay, what we'll do is we'll write a mail to everyone that we are decommissioning data bus. So we sent out this mail to everyone, we are decommissioning data bus. The rationale behind it was very simple. So if you tell somebody we are decommissioning a product, somebody is going to shout, no, I need it. Right? You need it? I'll tell you I'm not going to support it, then you will say, no, I need it, then I'll be able to bargain with you and say, okay, boss, give me the money. We are a cost center, we need money. But unfortunately, the power that we decided that that's not going to be, and we keep on running on. So we had a very nice guy who we hired for this purpose, paid him 6,000 rupees a week for 1.5 years, 18 months. And the good thing about it is that he essentially happened to make a lot of money and get out. his future was made. But the problem is it was a legacy thing and we did not really know who used it. We were just keeping something alive just because there was one property. I think it was weather which was said that they used it, but we didn't even know how much they really used. And we kept on running something just for the sake of running. So just we don't know who uses it, we just need to keep the lights on, let it be. So these are ways that you have organizations which keep on running and doing things. You should. So then the next one comes to, because I had a fair, I think that I can say that safely now. I think I possibly fell in the bad books of some of my seniors. So come 2008 December, they decided to end up. So I went to Thomson Reuters. Thomson Reuters was starting up a center here, which was basically going to support their Westlaw product. Westlaw is the preeminent law reference system that all lawyers use. It's a money maker. And when it's a money maker, you can be sure that technology is not something that they use a lot of technology, but they will basically use technology that is maybe expensive and not because they're more of a buy versus a bid concept. So one of the interesting things is that they had all these legal documents and all of these were actually stored in a huge Oracle database. I mean, that's what my thinking is, where Oracle databases are not meant to store documents. You would store a path to a particular file, you would store somewhere else, you could store it, but that's it, because that was there. And the guy who was the chief architect was actually a very good database guy, and he was doing NS order normalization sort of things. So you can be understood what sort of hardware we need to run a document database business. So the point is that because the only thing that's my understanding. I was a very, very junior person. But if the only tool that you have is a hammer, then every problem is a nail. The only thing if you know is the SQL database, then every problem is essentially an SQL database. Though people like Yahoo, we have done all the documentation and stuff, we have indexed the web, we know how certain things work. Happened. My network is running. You are in the meeting? Yeah. You are offline. Visitors have gone away. Oh, shit.
Just time short, so you just
Why does it time out?
the visitors have not participated.
Here for long period of time, right? Which is the meeting ID?
PIFCUICBCB. Last three is BCB.
Yeah.
Yeah, you're there. You are using companion mode.
Yeah, I don't know what that is anyways.
Yeah, you're back.
Yeah. So then the other interesting thing I found out was this problem, which I don't really know how much of it was there because I just heard about it briefly. They had a challenge comparing GUIDs. They would have stored certain goods in the database. And there was a problem whether goods should be compared in lowercase, uppercase, or how is it really compared to goods. I don't know. Is that a problem? I don't know. I am a bit confused. A good, if you treat it as string, you can always do a lower, too lower, and too lower, and compare some I don't know why it was a big problem. And then there were other problems also about open source, whether what open source they were using. That was a big problem. So there are 2-3 things that I have. And then I came to some of the issues I found in the real non-tech world, which is the real world. And this has to do with Aadhaar. This is interesting. First thing, You have, you know about the virtual ID thing concept in Aadhaar? Can you explain it? What are you supposed to do?
Kind of maps to your identity, but it's not taking the original number.
One day I saw Aadhaar.
Could be. I'm not sure how they implemented it, but the whole idea was that when people were starting to say that we don't want to give our Aadhaar numbers, the guy who was CEO of Aadhaar, Pandey, he came up with, it could be his idea, he's anyway technologically brilliant guy, so, or it could be somebody else's idea. So, but the idea was that instead of giving your Aadhaar number, you generate another one-to-one mapping, and you generate another number called a VID, and you can give that VID to your bank, and then bank or anybody else to use that VID. So they don't know your Aadhaar number, but at the Aadhaar database it links back. And so the interesting thing that they were doing was they did do this VID concept, but when you went to the UIDAI site and you downloaded your Aadhaar, it actually had both the numbers, the full Aadhaar and the VID. So I actually met those people and told them this problem. You see, you VID, then they realized, oh yeah, he can mask it. So now the next version, a few weeks later, they have done it that if you download it, the VID one, if you download the VID one, you get a mask Aadhaar with the VID which you can use and give it. But this is like, these are just things that you don't think of prior PSI, you don't think about it, what are the challenges. And another thing that really comes to that is the other problem that I have found was leakage in property transactions. This is something that I did some work on. Whenever you do a property transaction, whenever you do a registration, according to an act of the 2000 Registration Act, you are supposed to give your photographs and your fingerprints at the registration office. That photograph and fingerprint get put on the registration document, right? Now consider the fact that as your identity, you also are giving an Aadhaar number or a PAN card. If it's a PAN card, it's a different point. But if you are giving your Aadhaar number and they're using your Aadhaar number and putting it on the document, which they need to, so that they can be sure that it is you who got the property. You have the Aadhaar number there, on the other side you have biometrics also there. That's the significant leakage. This thing has happened because we did not think how two different laws conflict and contradict each other. And we did not do an analysis of what's going to be the impact of it. So I wanted to treat it as something like a property, like a information systems failure where we did not understand that legacy systems
It's 6 o'clock.
current systems when they meet there. So these are some of the challenges that I saw. These are things that I see as you learn. It could be you could call it technical debt, you could call it anything. But my whole idea is that over a few things you see a lot of technology which just gets mixed up in the real world. I think that's all for me. So I'm not sure there's going to be much, because there wasn't really much.
So you are not solving technology tech debts with a human factor. You kind of avoid it, or what is exactly?
I'm not avoiding it. I'm saying there are. So as I pointed out, this guy, these people who have written this book in 2021, they have actually pointed out they talk about social debt, they talk about architecture, design debt. All of these factors contribute to something that they call it. So the technical debt metaphor, I think, has taken over much bigger life than we thought it would be. Because everything can be lumped together with technical debt because it's a friction between what you want it to be and what you don't. And because it's a debt, you have to expend significant resources to pay it. So the fact that UDP came at a time when networks were, so you have a 128, you were using a file system, if I understand that, it's a design decision was because RAM was really expensive. It even is today, but we have been able to significantly reduce the cost. But at that time in 1990, when it was started on 1994, 95, 96, 16 MB RAM, 16 MB RAM was a huge amount of memory. I mean, we had PCs which were 8 MB, 4 MB. So when we have, at that we are talking about that time, then we have to have systems that work at that time. But over time you have to think about, rethink and rescale. Otherwise we get lost. And I'm not sure about this whole idea of
also if you talk about the cloud versus DC, and there are certain organizations which are actually moving out of the cloud because expensive storage. Storage is the most expensive component I've found in the cloud. Am I right, Devanshu?
Well, kind of.
I mean, just running a simple machine costs you just because you have the base.
I mean, data is the new oil.
Yeah, with the Ukraine war and crude prices being so, storage has a base.
Which book is this?
This book is Ernst Kasman and Delange. It's an MIT book. I got it at last. This is the book. Technical Data and Practice, how to find it fix.
And metaphor is a book which tells like metaphors change property.
Yeah. This is a pretty old book here, but it's a very nicely. I mean, I got only 7 chapters of this.
Don't change the slide.
Yeah.
I think when you talk about the technical depth with respect to today's time, I see just reflecting back like 10 years back, I was a lot like I want to divide it into 4 stages. Let's say .com era. When you talk about designing, system design, it was public policy was also policy at that point in time. Nobody used to think like how it has to become asset systems. And it was more of like a technology oriented field. But today, when you have a lot of like RAM is easily available, storage is easily available, network is easily available, then you think of designing of APA kind of systems, Aadhaar card, like kind of. Then you think of public policy, what's the design kind of thing, and then what I think in this book, the technical depth that he added in terms of like, public policy systems and then technology, and then entirely related more technical depth. Then you think of like how the design system and design system are comes from building blocks with policy.
Yeah, you're right. So this is an interesting point because that was actually the topic of my dissertation, which we talked about big data and policy. And my contention was that we need big data for policy, but we also need policies for big data. So we can use big data to make public policies, but in order to ensure that such data is available, we also need to have the policies that enable you to unlock the value that is inherent available there. So even today, when I was doing my research, I was trying to get data on, let's say, maternal mortality, child mortality. And I realized that even in today's era in India, we were actually doing a sort of a survey or a sampling of the mortality rate rather than using the everybody birthday is registered or at least 90% of cases there have been institutional deliveries. There will be primary health centers that have the data, but we have not been able to pick it up. We have not been able to. We have been able to build some infrastructure, but we have not been able to ensure that that data gets fed back. So these are large scale systems that are getting continuously improved, that need to be fixed. But you are right, things have evolved. So today the bigger challenges on the policy side is about privacy, about how to ensure data remains. So the recent hacks that have happened in claims, there's lots of patient data has off. But I mean, these are serious issues that we need to keep on concentrating and we need to be working on them, and that's where things are evolving and changing, and we need, and the thinking has to come in. Even today, lots of people, even government today, prefer to share email or their personal addresses over their government provided ones. And if you ask them why, they say it's more convenient.
Well, that policy decides like internet and electricity.
Huh?
I see electric organizations which are highly on software.
Yeah, but then you can't really force people to do certain things. No, that's the challenge, right? I mean, 90% of all queries in 2008 search queries went to Google from this building rather than going to Yahoo.com. Right? Right? I mean, that was the truth. Everybody was using Google as their search engine rather than using Yahoo.com as a search engine. So,
One interesting case which I found out like in Ireland in 2011 there was design rate of the system was made like no like all the people will found function at the same time and then the system will crash. So they do like kind of on the on-prem thing. I think they have shifted some kind of Redis from the Mohi kind of thing. So they have this pivotal Gen 5. So they basically did the entire transition and then within next subsequent months, we don't face that problem, especially during the cloud kind of thing. So,
but interrupting with you in the car, they also I was trying to do it. They actually block. I they do something rate limitation. Yeah, they do some rate limitation.
So basically they filter I think
actually the Chris railway reservation system. I was talking to one person, gentleman on railways about this topic. Just happened to randomly talk to him, and we got into talking about how Chris has evolved the system. You know, the first system that they built was actually running using Fortran.
Fortran 4, not Fortran 77.
Yes.
Fortran 4.
So it's so amazing that they were developing a system using Fortran 4 to do something which was traditionally a formal domain thing, a business process, and then evolved the whole thing over a period.
So I fortunately had these two people, Alok Bhattacharya and Ratin Ghosh. They were like CMC stalwarts who were like in those days they were told like if Alokda knows which computer to kick to make it work, you will know. So these two were the stalwarts who built up some during my government hood had some interaction with them who worked with at least one of them. I mean, but then later they said that what you were talking about, like I was just before joining Yahoo, that those are the days. So they said that this is a lot of transitions. But the initial system was Fortran 4.
But exactly this was the same reason why he was standing on the reservation counter. Your reservation is getting very fastly running versus when you are trying to do it over a STP. The request response times the latency is too high, and the system is getting crashed. But
yeah. So I think it's also important to understand that how the systems have been connected also.
Yeah.
When you are running a system on the reservation thing, most of the PRS was actually handled with the local terminal. And the PRS system would be interconnected with high-speed link lines. Whereas you are connecting it over a 2 Mbps link, वो भी आधे टाइम काम करता है when you are, I mean, this so the interesting, yeah, so KBPS. So KBPS was when I joined CDAC in 1996. We had a 64 kbps radio link over whom the entire office of 100 plus people used to run Netscape browser. Today you give that kbps thing to a kid and he is going to slap you right. That's the sort of thing we evolved. And nobody cared. So we were very happy to have the internet.
Okay, so we are slightly like 8 minutes over the time, and thanks to Sachin. I mean, it was very glad. Sachin agreed to come over, and thanks, Sachin. I think I will give it to Raj for thanks part and stuff.
Thank you very much for coming here on a Saturday whole day. I know we didn't expect this much crowd, but that's great. I think we understand after 3 years we are meeting, and then obviously Yahoo, it brings a lot of nostalgic memories for all ex Yahoo. So great to see all that, and hopefully we'll continue to see this kind of attendance in the future versions. Obviously by now you know that every who is our part of the community, I think they take turns to kind of host this. We had a virtual session, now we have started off the physical one. Hopefully we'll get to see more. And like I said at the beginning, I think we need to be advocate of this meetup. We need to be talking to our leadership. We have to make it a global kind of a setup. Right? It is national already, we see that. But yeah, that should be our collective vision. And whatever I think today's sessions were all interesting, all from different backgrounds. I know UDP is something that everybody was more focused on, and I liked the Intuit one. They gave a problem statement, right? Okay, this is a problem statement, and they are looking for options, and I think that exactly is what this whole setup is for, right? So that we learn or we propose solutions for other problems. So with that, I think we'll end the session, but I would also please I invite all the speakers first, and as a tradition, we will give goodies. And for all the attendees, if you before you go out, please go to the cafeteria. We have some snacks. Before you get the snacks, there are goodies for you. Please go. There is secretary team there, so they will take your name and they will hand over to you. So before you, please take that. Okay, that thank you all.
Speakers to the dance, please.
Yeah, speaker.